Hello, my name is Andile and welcome to Soul for Eggs. Please don't skip this intro as it is very important. This video covers everything that you need to know to get a minimum of 60% and above in this section of the paper. It is very important that you watch the video in order. Why? Because as we move along, we're going to come across some concepts that I've already explained earlier in the section. So I won't be going deep into them again. They've already been broken down properly before. So there is no need to repeat as already I've explained it in a deeper sense. This video is going to be broken down into 6 sections, which is going to be section 1, solving quadratic equation, section 2, quadratic inequality, section 3, simultaneous equation, section 4, nature of roots, section 5, exponents, and section 6, surds. This video is pretty long, so to help you out, I've added timestamps in the description. You can use them to jump to specific parts if needed. Again, right? Just very important. Only use it to jump into sections if you already know the fact that the previous sections you already understand. If you don't understand, make sure the fact that you go in order. As I said, the fact that everything is a build up. Hope that makes sense, right? So with that said, we can start with the video.
So now we're going to move to factorization, and I'm just going to draw a diagram or a situation of what's factorization so that you can understand it visually what we're doing, right? So if we have the following, right? So if we have the following, so let me take my pen. So if we have the following, which is 2, right? Then this is going to be x plus 1, right? When we take this and we basically multiply, right, or we expand this, what we've been doing this whole time when I was saying multiplying a binomial or trinomial is called expanding, right? When I expand this, you know the fact that I'm going to get 2x, right? Then this is going to be plus 2. This is the expand version of this, right? So from going to this to that, we know the fact that we are expanding, right? This is called expanding, right? So what happens now if we had this and they want us to go back here? So now what happens if I have this, they gave me this, but they want me to go back to this where brackets are involved, right? So this is now called factorization. So that's the difference. So this is going to be called factorizing, right? So remember the fact that if you have in terms of a bracket like this, and you go here, this is called expanding, right? Finding the product, right? Multiplication, this is the same thing. This is expanding. When you have now individual terms, do you see that? But now when you go here, when you have brackets, the minute you see brackets, you have factorized it. I hope that makes sense, right? What is the difference between expanding and factorizing? So now, remember the fact that this whole time when we were doing the products, we were given this and we needed to find this, right? But now what we're going to do is the opposite. Now we are going to be given this and they're going to want this one. So that's what's going to be happening. Remember the fact that finding the product, we had this and we were going in this direction. Now we basically not going to be given single terms, right? And they're going to be wanting us to write it in terms of brackets, right? Remember with factorization, your final answer needs to have brackets. If you don't have brackets, you're doing something wrong, right? Then with expanding, you shouldn't have brackets. So if they say expand something and you have brackets, you are doing something wrong. I hope that makes sense, right? So that's the note on basically what is factorization. So now what we're going to do is we're going to look at the first example under common factor. So this is how the example goes. And we need to find what? The common factor. So we see the fact that the only common factor that we can take out is from the coefficient, which is 6 and 2, right? So let's do that. To find the factor that we can take out, we need to find the highest common factor. So now we need to find the highest common factor, right? So we're going to take each coefficient and find their factors. Then take another one. Then we're going to look at the ones that are common and we're going to take the highest one. So let's look at 6. So it's 6. We have 1 multiplied by 6. Then we have 2 multiplied by 3. Then now for 2, we have 1 multiplied by 2, and these are the only factors. Now, to find the highest common factor, we need to look at the factors for 6 and the factors of 2 and find what their common factor before we find the highest common factor. So we see the fact that 1 and 1 is common. We see that 2 and 2 is common. So now to find the highest common, highest common factor. So we found the common factors. We need to find the highest common factor. So the highest common factors in our case is going to be what? It's going to be 2, right? So now we know that the highest common factor is equals to 2, right? So now we're going to take that 2, we're going to write it here, then we're going to open our bracket. Then after opening our bracket, what we need to do is we need to find each term that goes inside the bracket. And to do that, what we'll do is we need to take each term and divide it by the highest common factor. So the first term is 6x squared. So we're going to say 6x squared divided by what? Divided by our highest common factor, which is 2. Then 6 divided by 2 is going to give us 3. Then this 2 is just going to go down, which is going to be x squared. So here, the first term is going to be 3x squared, right? So now we need to find the term that's going to go here. So we're going to say what? We're going to say negative 2, divided by our highest common factor, which is 2. Then that's going to be equals to negative 1. So the term that's going to come here is going to be negative 1. And this is our final solution. Now let's look at example number 2, right? We have 4x plus 12x squared. Then we need to find the common factor. So first we need to look at what? When finding the common factor, we need to look at the common factors of the coefficient, which is 4 and 12. Then after that, we're going to look at the common factors between x and x squared. But first, let's start with the coefficient, which is 4 and 12. So on the side, let's write the factors of 4. So we know the factors of 4 is 1 multiplied by 4. And the second one is what? 2 multiplied by 2, right? Now, let's go and find the factors of what? Of 12. So we know that 12, the factors of 12 is going to be 1 multiplied by 12. Then the second one is going to be 2 multiplied by 6. And the last one is going to be 3 multiplied by 4. Then now what we do is we're going to circle the common factors. So the common factors is 1 and 1 here. And the other one is what? 2 and 2 here, right? And we have 4 and 4 here, right? So we have circled the common factors, right? Then now we need to find the highest common factor. And the highest common factor is the one with the big number. The ones from the circle, the one that's large is our highest common factor. So we see that 4 is our highest common factor. So we know that 4 is our what? Our highest common factor. So we're done dealing with the coefficient, right? Now, what we're going to deal with, we're going to deal with the x's, right? So to deal with the x's, let me change the color of my pen so that you guys can see it properly. Let me do it in pink. So we have x and we have x squared. To see which one to see our highest common factor, we take the one that has what? The least or the lowest degree. The x value that has the lowest degree. And we see the fact that this is x to the power 1. So here, our highest common factor is going to be the one with the less degree, which is going to be just x, right? So now to find our highest common factor for the whole thing, which is I'm going to write writing it in another color, which is in yellow. Our highest common factor for this whole thing, so our highest common factor is going to be this one multiplied by this one. So it's going to be 4 multiplied by x, which is going to give us 4x. So this is the one that's going to go outside the bracket. That's our highest common factor for this question. So we're going to write 4x here. Then we're going to open a bracket. Then we're going to close the bracket. Then we need to find each term that comes inside the bracket, right? So to do that, what we're going to do is we're going to take each term and divide it by what? Divided by our common factor, right? The general one. So what we're going to do, we're going to say, we're going to do it in yellow. We're going to say 4x divided by 4x. 4x divided by 4x is going to be equals to 1. Then we're going to say 12x squared divided by what? By 4x is going to give us what? 3. X squared divided by x is going to be the same as x. So this is the term that's going to go inside. So it's going to be 1 plus 3x. And this is going to be your final answer. So now we're going to do a question about solve for x, but we're going to talk about when it's in common factor, right? So it says solve for x. So we have it like this. Let me just change my pen. So what we need to do is that we need to factorize. And here, how do we factorize? It's taking x as a common factor, right? So taking x out is going to be x, open bracket, it's going to be 3x, and it's going to be plus 1, and that's going to be equals to 0. Then what we're going to do is that we're going to basically equate x into 0 and this bracket into 0. So it's going to be the same as x is equals to 0, or it's going to be 3x plus 1 is equals to 0, right? So this one is going to be the same because nothing is going to change. And this one, we're going to take the 1 to the other side because we want x alone. So it's going to be 3x is equals to negative 1. Divide both sides by 3. So it's going to be the same as x is equals to negative 1 over 3. And that's how you would solve this question. In order to solve difference of 2 squared, we need to first make sure that our expression or our equation satisfies this 3 condition and need to satisfy all of them. So the first one says that the expression or equation has 2 terms. Then the second one says each term having a different sign, meaning one term is positive and the other one is negative. Then it says each term must be a perfect square, right? To check the fact that each term is a perfect square, we're going to use square root. So now to see how to put this into play, let's do the first example. So now let's look at the first example. Our first example is x squared minus 1. Let's check whether this expression satisfies the 3 conditions. The first condition says that the expression or equation has 2 terms. We have x squared, which is 1 term, and negative 1, which is the second term. So it satisfies the first condition. And the second one says each term having different signs. X squared is positive and negative 1 is negative. So each term does have different signs. So this one is satisfied. Then the last one says each term must be a perfect square root. So we need to check whether x squared and 1 are perfect squares. So let's do that. So we're going to take a square root and we're going to say x squared is equals to x squared is going to be equals to x. So x squared is a perfect square. Then the second one is 1, which is square root of 1 is going to give you 1. So 1 is a perfect square. So each term is a perfect square. So this condition is satisfied. Then after that, you're going to open to write your final answer for factorization here. You're going to open 2 brackets like this. You're going to take the one that you got from the square root, the final answers, which is this and this. Then you're going to write it here. You're going to say x here, x here. Then you're going to take 1 and 1. Then you're going to say what? Plus or minus. Then you're done solving this question. So now let's look at example number 2. We're going to check whether our expression satisfies all these 3 conditions. So the first condition says the expression or equation needs to have 2 terms. So we have 1 and 2 terms. So this one is satisfied. Then they say each term having different signs. 4x squared is positive and negative y squared is negative. So this one is satisfied too. Then the last one says each term must be a perfect square. So let's check whether each term is a perfect square. We have square root of 4x squared, which is the first term. It's going to give us the square root of 4 is going to be 2. The square root of x squared is going to be just x. So this one is a perfect square. Then the second one is y squared. So the square root of y squared is going to give us y. So each term is a perfect square. So this one is satisfied. So let's write 2 bracket to factorize it. You're going to say 2x here. Then 2x here, then you're going to say y and y, then you're going to say plus or minus. So this is going to be your final answer. So your question is solved. So now let's look at example number 3, right? First, before we check whether it's a perfect square, let's rearrange our equation so that the x term comes first. So let's do that. The one with the variable, which is x, comes first. So it's going to be x to the power of 4 minus 49. Then now after this, we can check whether it satisfies our condition, right? So the first condition says the expression or equation has two terms. We have two terms. We have x to the power 4 and negative 49. So this condition is satisfied. Then they say each term having different signs. X to the power 4 is positive and negative 49 is negative. So this one is satisfied too. Then the last one says each term must be a perfect square. So let's check whether each term is a perfect square. If we take the square root of x to the power 4, and we're going to get what? X to the power 2, making x to the power 4 a perfect square. And the next term, which is square root of 49, which is going to be square root of 49. The square root of 49 is going to give us what? 7, meaning each term is a perfect square. So this one is satisfied. Now we're going to write two brackets like this. Then when we write two brackets, we're going to say x squared here. Then we're going to say 7 and 7. Then you're going to say what? Plus or minus. So this will be your final answer when you're done factorizing. So we are done with this example. So now what we're going to do is we're going to do solve for x, but now it's a difference of 2 squared, right? So we see the fact that this is a difference of 2 squared. So we are going to have two brackets. So it's going to be x minus 8, right? And it's going to be x plus 8 is equals to 0, right? Equate both brackets by 0. So it's going to be x minus 8 is equals to 0. Then it's going to be, or it's going to be x plus 8 is going to be equals to 0. So solve x. So take the 8, the negative 8 to the other side. So it's going to be x is equals to positive 8. And this one, take the 8 to the other side. So it's going to be x is equals to negative 8. Then this can be also written as this, which is x is equals to plus or minus 8. Because you see the fact that you have a negative 8 and a plus 8. So this or this is basically the same thing. So that's how you would solve this question. So now what we're going to do is we're going to do questions that deal with quadratic formula, right? So with the quadratic formula, first let me write the quadratic formula here. So this is the quadratic formula. It says x is equals to what? Is equals to negative b, right? This is going to be plus or minus square root, right? Then inside here, you're going to have b squared minus 4ac, right? And this whole thing is going to be divided by what? It's going to be divided by 2a. So this is the quadratic formula, right? So this is the formula that we're going to use. So now let's talk about when we're going to use quadratic formula. So it says solve for x. How do you know when you get to the exam that you're actually using quadratic formula? They'll always have a bracket next to it saying the fact that leave your answer into 3 decimal places. The minute you see that, don't even bother yourself to factorize, right? Using all the methods of factorization. Just go the fact that, okay, cool, I need to use my quadratic formula, right? So that's that. Then the second thing is that you need to make sure the fact that your equation is in the standard form. What is the standard form? It's actually ax squared, right? Plus bx plus c is equals to 0, right? So it needs to be in standard form first. So that's what we need to do. Do we see the fact that our equation is not in standard form? So that we need to sort that out, right? So it's going to be what? It's going to be now 2x squared plus 3x. Do you see the fact that the 7 is on the other side? So we need to take it here. So it's going to be negative 7 is equals to 0. So now it's in the standard form. Then the third thing that we need to do is that we need to identify a, b, and c so that we can substitute into the equation. So let's do that. So a is the coefficient of what? Is the coefficient of x squared. So we see the fact that a here is going to be equals to 2, right? Then do you see the fact that b is the coefficient of x? So here, therefore, b is going to be equals to 3, right? Then we see the fact that c is the constant. So here, c is going to be equals to negative 7. So now we have our a, b, and c. So that's beautiful. That's sorted, right? So now what we're going to do is we're going to substitute our a, b, and c into our quadratic formula. So let me just write it. It's going to be x is equals to what? To negative b, right? Plus or minus, that's going to be the square root, right, of b squared minus what? Minus 4a, right? 4ac, right? And this whole thing is going to be divided by what? Divided by 2a. So now we're going to substitute our a, b, and c. So it's going to be x is equals to negative, then open bracket, always put your numbers inside the bracket. So it's going to be negative, positive 3 here. It's going to be plus or minus, then this is going to be the square root, right? And here's going to be what? It's going to be 3 all squared minus 4 then this is going to be 2, right? And this here is going to be -7, right? And this whole thing is going to be divided by what? It's going to be divided by 2. Then this is going to be 2. So that's everything that we need, right? So now what I'm going to do is that I'm going to just pause and freeze the screen here. Then on the side, I'm going to show you using your calculator on how to solve this, right? So now you're going to have your calculator. Then you're going to check the fraction sign, right? Then after checking the fraction sign, you're going to substitute all the values, your A, B, and C. So you're going to say negative. Then you're going to open your bracket. You're going to say 3. You're going to close your bracket. Then do you remember the fact that it says plus or minus? You're just going to pick the minus. Then you're going to press minus. Then you're going to say square root. You're going to open your bracket. You're going to say what? You're going to say 3 again. Then you're going to close it. Then you're going to say all squared, right? Then you're going to say minus. Then you're going to say 4. Then you're going to open your bracket. Then you're going to say 2. Then you're going to close it. Then you're going to open your bracket again. You're going to say -7, right? Then you're going to close your bracket. Then you're going to press the down button just to go down. Then you're going to say 2. Open your bracket. Then you're going to say 2 again. Then you're going to close it. Then you're going to say equals to. Now you want to change this value into decimals, and you're going to press this as D to change it as decimals. And this is going to be your value, -2,7, which was running off to 2 decimal places. So it's going to be 7, right? But now we want to move on to when now in this formula it's positive. So first to do that, we're going to click the up button to change it back to this. Then you're going to click this button to go back into the function. Then you're going to basically click it like this, because now we want to change the negative into a positive, right? So you're going to say delete, then you're going to say positive, right? Then you're going to say equals to, then you're going to get this. Then to get into decimal, you're going to say SD. Then this is going to be value that you're going to get. So just another thing that I just want to show you guys, or just want to emphasize, do you see the fact when I was dealing with negative numbers, I didn't press this negative, I pressed this one. Do you see this one? This one deals with numbers, with the negative that's in front of numbers. This is the same as addition. This negative here is like the same as addition and subtraction. That is why it's going to be here and here, right? But this negative here and this negative is 2 different negatives. The other one relates to like when you have a -3, -4, -5. Then the other one is the same as like -2. Like when you say 1 minus 1, then this is the negative that you're going to use here. So that's all I wanted to say. So what you're going to get from us using the calculator, you're going to get the following. You're going to get that x is equals to what? It's equals to simplifying it, right? So we need to simplify it. Remember the fact that we need to round off to what? To how many decimal places? We need to round off to 2 decimal places. So x is going to be equals to, so x is equals to -2, right? 2,76, right? When we add a negative here. So 2,76, remember the fact that it's rounding off to 2 decimal places. So let me just erase this because we're rounding off. So it's actually 2,77, right? Rounding off. Or, right, when we put a positive here, is that x is going to be equals to what? It's going to be equals to, it's going to be equals to 1,27. So this will be your 2 answers, right? So that's how you would solve quadratic. This is how you would solve for x using the quadratic formula. So now we're going to move to solving, solving for x when we have it in a trinomial, right? So I'm going to teach you the cheating way. And this here, when it says pencil work, going to emphasize it. You are not allowed to show this work in, like, the person that's marking your paper, should they see this? It's either you need to do this work on your question paper, or if it's going to be on your question paper, or if it's going to be on your answer book, which is I suggest not to do that, is that you need to do it in pencil so you can erase it. So that you don't forget and you don't do any mistakes, do it on your question paper on the side, right? Because it's going to be very quick. Then after that, take whatever, we're going to translate it here. So that you can see which word needs to be in pencil, it's going to be in red. Then your final answer is going to be in blue, right? So to use this system, we're going to cheat the code, right? We're going to cheat. We're going to do a little bit like cheating, right? But this cheating is for good because they're not going to know, right? They're not going to know. So the first thing that we need to do is that we're going to use the quadratic. As before this, this video is that there was a quadratic. So I've showed you on how to punch into the calculator using the quadratic formula. I've done that. So we're going to use the same thing, but we're going to use it to factorize this, right? So the first thing is that you're going to have your quadratic formula like this. Then you're going to basically write this in a form of ax, right, plus bx plus c is equals to 0. So it needs to be in this form, which is in our case, it's good, it's in that form, right? Then what you're going to do is that you're going to write a, b, and c. So we see the fact that here our a is 1. You see that our b is 8, and we see that our c is positive 15. Then you're going to substitute into the quadratic formula. So it's going to be negative, open bracket 8. Then it's going to be plus or minus, open the square root. Then it's going to be 8 all squared. It's going to be minus 4. Then it's going to be 1. Then it's going to be 15, right? Then that whole thing is going to be divided by 2 multiplied by a, which is 1, right? Then punch it into the calculator. You're going to get 2 x values. You're going to get the first one, which is going to be x is equals to negative 3. Then the last one is going to be x is going to be equals to negative 5. So that's nice, right? But this is like the final answer when you're done. So right now, I need 2 brackets to factorize this. So I'm going to take the negative 3 to the other side, which is going to be positive. So it's going to be x plus 3 is going to be equals to 0, right? And we're going to take the negative 5 to the other side. So it's going to be x plus 5 is equals to 0. So this 2, let me just highlight them. It's going to be what? It's going to be your 2 brackets, right? So now I'm going to change my pen. So when I change my pen, so when I change my pen into blue, this is what you're going to write. So you're going to have 2 brackets. The first one is going to be x plus 3, and the other one is going to be x plus 5, and you're going to say this is equals to 0. So this is your 2 brackets, right? Then you're basically going to solve it. So you're going to equate 2 brackets by what? By 0. So you're going to basically go back here, right? So it's going to be x plus 3 is equals to 0, or it's going to be x plus 5 is equals to 0, right? Then we're going to solve for x. So this one is going to be the same as x is equals to negative 3, or it's going to be x is equals to negative 5, which is exactly what you got. If you don't get the same thing, then there's something that you did wrong here, right? So you're basically going to go from here into here, and that's going to be your final answer. So that's how you would use the cheating method, right? So that's how you would do it with this question. So now we're going to do example 2 using the cheating method, right? So what we need to do is that in this question, we have negative x squared minus x plus 20. So what we need to do first is that we need it into being this ax squared plus bx plus c, right, is equals to 0. We need our a to be positive. So what I'm going to do is that I'm going to take the negative out as a common factor, because I don't want anything to be negative. I want this one to be what? To be positive. So when I take it out, anything that was negative before becomes positive, and anything that was positive becomes negative. So since this was negative x squared, it's going to be positive x squared. This was negative x, it's going to be plus x. And this one is positive 20, so it's going to be negative 20. And this is going to be equals to 0, right? Then we're going to divide. If we divide both sides by negative 1, this one's going to be positive. And 0 divided by any number is still going to be 0. So you're going to have x squared plus x minus 20 is equals to 0. Because anything divided by 0, whether it's negative 1 or 2, it's always going to be 0. So that you're going to have it like this. And now we see that our a is positive, so which is what we want, right? So remember the fact that we always want our a to be positive. Then with that said, now we're going to go to our cheating part, right? So now we're going to indicate what is a, b, and c. So we see the fact that a is 1, b is 1, but c is negative 20, right? Substitute it into the formula. You're going to have x is equals to negative, then this is going to be 1, plus or minus, it's going to be the square root, that's going to be 1 squared, right, minus 4, then it's going to be 1, then it's going to be negative 20, right? And this whole thing is going to be divided by what? It's going to be divided by 2a, which is 1. So x is going to be equals to what? It's going to be equals to 4, or x is going to be equals to what? It's going to be equals to negative 5, right? So that's sorted. So now we need 2 brackets. So I'm going to take the 4 to the other side. So it's going to be x minus 4 is equals to 0. Or here it's going to be x plus 5 is equals to 0. So this are going to be your 2 brackets. This 2 are going to be your 2 brackets. So let's do that. So having them as your 2 brackets, you're going to have the following. You're going to have that in blue. Remember the fact that red is the one that's going to be in pencil work, the fact that one that you're going to erase. So you're going to have that, you're going to have x minus 4, and another bracket is going to be x plus 5, and this is going to be equals to 0, right? So now we're going to equate each bracket by 0. So it's going to be x minus 4 is equals to 0, or it's going to be x plus 5 is equals to 0. So therefore, it's going to be the same as x is equals to positive 4, or it's going to be x is equals to negative 5, which is exactly what we got when we used the quadratic formula. So that's how you would do this equation. And remember that the pencil work, you need to erase it when you're done. So now we're going to move to example 3, right? So example 3 is when our a is not 1, but it's another number, right? So that's the example that we're going to do. So we see the fact that it's in standard form, which is perfect. Now let's indicate what's A, B, and C. So we see the fact that A is 2. We see that B is 5. And we see the fact that C is negative 3. So substitute that. So it's going to be x is equals to negative. Then it's going to be 2. No, not 2. It's going to be 5. Because that's B, the mistake. So it's going to be 5, right? And it's going to be plus or minus. Then it's going to be the square root. And this is going to be what? 5 all squared minus 4. Then this is going to be 2. And this is going to be negative 3. Right? And this whole thing is going to be divided by what? By 2 multiplied by 2. Then when you punch that into the calculator, you're going to get your x is going to be equals to 1 over 2. Or x is going to be equals to what? To negative 3. So with this one, do you see the fact that our x is a fraction? So now I want to basically get rid of the fraction. So this I'm going to divide it by 1. And we're going to cross multiply for this one. So if we say 2 multiplied by x, we're going to have 2x is equals to 1 multiplied by 1 is going to be 1. And this one, just take the 3 to the other side. So it's going to be x plus 3 is equals to 0. So now we're going to take the 1 to the other side. So it's going to be 2x minus 1 is equals to 0. Then this are our 2 brackets. This is going to be our 2 brackets, the one that we're going to use. So you're going to have 2 brackets. Then now I'm going to change my pen. So it's going to be 2 brackets, which is going to be 2x, right? Minus 1. Then the other one is going to be x plus 3. And this is going to be equals to 0. Then now we're going to equate both by what? By 0. So it's going to be 2x minus 1 is equals to 0. Or it's going to be x plus 3 is equals to 0. Take the 1 to the other side. So you're going to have 2x is equals to 0 is equals to positive 1, sorry. And here it's going to be x is equals to negative 3, right? Which is exactly this. Then now we're going to divide both sides by 2. So it's going to be x is equals to 1 over 2, which is exactly this one. So that's how you would solve this equation. So now let's do example 4. It's the same as example 3, but now it's negative, right? So what we need to do is that we need to get rid of the negative. So let's do that. So take out the negative as a common factor. Everything that was negative becomes positive, and everything that's positive becomes negative. So this one's going to become 7x squared, and this one's going to be negative 6x, and this is going to be negative 1, right? And this is going to be equals to 0. Then to get rid of the negative, anything divided by 0 is going to be 0. So this is the same as 7x squared minus 6x minus 1 is equals to 0. So that is sorted, right? So now we see the fact that it is a positive a. Now we can indicate our a, b, and c. So let's do that. Pencil work. So our a is 7, our b is negative 6, and our c is negative 1, right? Then now substitute in the formula. So it's going to be x is equals to negative. Then it's going to be negative 6. Then this is going to be plus or minus. And this is going to be the square root. And this is going to be what? Negative 6 all squared minus 4. Then this is going to be what? 7. And this is going to be negative 1. Right? And this whole thing is going to be divided by what? By 2. Then this is going to be 7, right? When you punch that into the calculator, you're going to get that your x is equals to 1, right? Or your x is going to be equals to what? It's equals to negative 1 over 7. Remember that it's a fraction, so we need to get rid of it being a fraction. So what we're going to do, this is going to be the same as divided by 1, and we're going to cross multiply. So when you say x multiplied by 7 is the same as 7. X, when you say 1 multiplied by negative 1, it's the same as negative 1, right? So now I'm going to take the 1 to the other side. So it's going to be x, then it's going to be negative 1 is equals to 0. Then this one, take it to the other side. So it's going to be 7, right? X, that's going to be plus 1 is equals to 0. So making our new brackets, which is going to be this one and this one, right? That's our new bracket. So now we're going to basically write it here. So it's going to be what? It's going to be 7x, right? Plus 1. Then it's going to be x minus 1 is equals to 0, right? Equated by 0, the two brackets. So it's going to be 7x plus 1 is equals to 0. Or it's going to be x minus 1 is equals to 0, right? So now here, take the 1, negative 1 to the other side. So it's going to be x is equals to positive 1. And here it's going to be 7x, take the 1 to the other side is equals to negative 1. Divide both sides by 7. So it's going to be x is equals to negative 1 over 7, which is exactly the same thing that we got here. So that's how you would factorize for number 4. So now we're going to do example 3, right? With example 3, they say solve for x, but they give us 2 brackets. If you just look at the equation, we already factorized it, right? Do you see the fact that our goal is to first factorize? And I'm just going to go to number 1. Do you see the fact that our goal is to write it in this form? And when we have it in this form, we know the fact that we can equate each bracket by 0, right? So do you see the fact that example 3, that's what they gave us. So here to solve this question is going to be the following. It's going to be just equating each bracket by 0. So it's going to be x plus 4 is equals to 0. Or it's going to be 5x minus 4 is equals to 0, right? So this is going to be, take the 4 to the other side. So it's going to be x is equals to negative 4. So we're done with that one. So now let's solve this one. We're going to take the 4 to the other side. So it's going to be 5x is equals to positive 4, right? Divide both sides by 5. So it's going to be 5x divided by 5 is equals to what? To 4 divided by 5, right? So this is going to be the same. The 5s are going to cancel out. So this is going to be the same as x is equals to 4 over 5. So this will be your 2 answers for this question. So now we're going to move to example 4, right? If you look at it, is that example 3 and example 4 are kind of similar. The difference with example 4 is that this is not equals to 0. Very important, right? You can only do example 3 like this if it's equals to 0. If it's not equals to 0, then you can't say that x plus 4 is equals to negative 60. No, you can't do that. You can only equate it to 0, right? So what do we need to do here? We need to make sure the fact that our equation is in this form, which is going to be x squared, ax squared, right, plus bx plus c is equals to 0. So I need to get rid of the 16 so it can be 0, right? But first, do you see the fact that I have brackets? I need to get rid of the brackets. And why? How can we do that? We can do that by expanding, right? So let's expand that, right? So when we expand, we're going to have the following, right? So when we expand, we're going to have the following. We're going to have the fact that it's going to be 5x squared, right? Then this is going to be minus 4x, right? And this is going to be what? Plus 20, right? X. And this is going to be minus what? Minus 16. And this is going to be equals to negative 16. How did I get there? I said x multiplied by 5x, which gave me 5x squared. Then I said x multiplied by negative 4, which just gave me negative 4x. Then I said, now I went to 4. Then I said 4 multiplied by 5x, which gave me 20x. Then I said what? I said 4 multiplied by negative 4, which just gave me negative 16. I hope that made sense. So that's how I did it. Then after that, let's clean this up and group like terms, right? So grouping like terms is this one and this one, right? So now let's write. We know the fact that we're going to have 5x squared. Then if you say negative 4, right? What you call this, negative 4 plus 20, I'm going to get the fact that I'm going to have plus 16x, right? It's going to be minus 16 is equals to negative 16, right? Remember the fact that we need it in this form, right? Meaning I need to get rid of this negative 16, take it to the other side so that we can have a 0. So we're going to have 5x squared, right, plus 16x, right? Then it's going to be minus what? Minus 16. Then here's going to be plus 16. And this is going to be equals to what? It's going to be equals to 0, right? So now let's group like terms. We know the fact that's going to be 5x squared plus 16x. And negative 16 plus 16 is going to give us 0. So this is going to be basically equals to 0. Do you see the fact that this simplified version is exactly like this? So that's great, right? So now we look at our simplified version and check. Yes, we can factorize by taking what? By taking x as a common factor. So that's what we're going to do. So we're going to say x, right, as a common factor. What's going to be left here? We're going to be left with 5x, right? And this is going to be plus what? It's going to be plus 16, right? So it's going to be plus 16. Close your bracket is going to be equals to 0, right? So what do? We're going to equate each term by 0. So here, do you see the fact that we just have x, right? So you're going to take this x and you're going to equate it to 0. So we know the fact that x is equals to 0. Or you're going to take this bracket and equals to 0. So it's going to be 5x plus 16 is equals to 0. So now we're going to solve for x here, right? We're going to take the 16 to the other side. So it's going to be 5x is equals to negative 16. Divide both sides by 5, right? So it's going to be 5x divided by 5 is equals to negative 16 divided by 5, right? So the 5s are going to cancel out here. So therefore, x is going to be equals to what? To negative 16 divided by 5. So that's how you would solve this question. So now we're going to do inequality, and I kind of changed it into a table form because I feel like it's going to be more easy if while doing it, you ask yourself this for the equations, right? So you're going to do the first one, but first let's understand the table form, right? Is that you're going to have your equation, which is the inequality. Then you're going to ask yourself, is this in standard form? And remember that standard form is what? It's ax squared plus bx plus c. This is its standard form. And if you say yes, this is the 4 options that it needs to look like. It's this one where it's ax squared plus bx plus c is less than 0. Or it could look like this one, or it could look like this one, or it can look like this one. If it looks like either one of the 4, then you're going to say yes. If it doesn't look like either one of the 4, you're going to go and say no, right? Then from no, you need to write it in standard form, right? Then after writing in standard form, you're going to go back here and basically indicate which one it is, right? But then after that, you're going to indicate whether you're going to be looking for positives or negatives, right? So if it's either this 2, it's going to be looking for positives. If you're looking for either this 2, it's going to be negatives. Then you're going to indicate, right? Then if you're in this side, you're going to go down. You're going to check whether is it equals to, is it just greater than, or is just greater than and equals to. Then either one of all, you're going to indicate. Then you're going to just solve the question. So I think the best way is just to show you in action, right? So now let me take my highlighter so it can make sense. You ask yourself, is this in standard form? We look at it. Yes, it is in standard form. So you're going to go the yes root, right? And after saying the yes root, and I'm just going to take my pen, I'm going to just mark, I'm going to mark which type it is. Do you see the fact that is it's x squared, then it's greater than 0. So we're going to indicate the fact that it's this one, right? It's this one, not the greater than and equals to, but just this one, right? So we know the fact that it's this one. So now, since we know the fact that it's this one, and I think it's good to highlight it, let me just highlight it. It's going to highlight both of them. That's why I don't want to highlight it, right? So now we know the fact that it's this one. We're going to check whether our sign is going to be positive or negative. Do you see the fact that it's greater than, meaning it's going to be this one? It's going to be this one, right? Do you see the fact that it's going to be this one, meaning it indicates the fact that we need to look for positives, right? So we're going to go this direction, right? So we know the fact that it's the first one, right? Then the next one is that, is it greater than and equals to just greater than? We see the fact that we end here, so it's going to be just greater than. So we're going to go this direction and this one. So our answer needs to be curved brackets, right? And this one. So we know the fact that this is how it is. So now after indicating in this flow diagram, right, which things that we need to use, now we can solve the question, right? So now the first thing that we need to do is we need to factorize, right? So when we factorize this, we're going to have the following. We're going to have that x minus 3, right? And we're going to have x plus 5, right? It's going to be greater than 0. So we done factorizing. The reason why we're factorizing is because we need critical values. So we're going to find critical values. Our critical values is equating both brackets by 0. So this is going to be the same as x, right, minus 3 is equals to 0, or is going to be x plus 5 is equals to 0. And please indicate the fact that this is critical values and this is not your final answer, right? So this is going to be x is equals to what? To positive 3. And here's going to be x is equals to negative 5. So you have your two critical values, which is positive 3 and negative 5, right? And now you're going to use the critical value to basically indicate on the number line. So let's draw a number line, right? So you're going to have your number line, and this is going to be what? This is going to be negative 5, and this is going to be positive 3, right? And this is going to be negative infinity, and this is going to be positive infinity. Very important to indicate negative infinity and positive infinity, because this is going to be either going to be part of our solution. Then we're just going to indicate the critical values by dotted line like this, right? Then the next step, what you're going to do is that from negative infinity to the first critical point, you're going to pick what? You're going to pick a value between those number, right? From negative infinity till negative 5. And I pick negative 10, right? Then from negative 5 till 3, I'm going to pick a number between there. Then it's going to be 0, because 0 is in between these two. Then from 3 till positive infinity, pick any number, right? That is between 3 and positive infinity, which I picked 5, right? So that is sorted. Then what you're going to do is that you're going to take this function, right, that you had put in standard form, if you need to put it in standard form, you're going to take that thing and you're going to substitute the numbers that you picked, right? So we know the fact that this is going to be x squared plus 2x, right, minus 15. So now we're going to substitute negative 10. So it's going to be negative 10 all squared plus 2, that is going to be negative 10. And this is going to be minus 15, right? Then you're going to have what? 0. So it's going to be 0 squared plus 2, that is going to be 0. There's going to be minus 15 is equals to, then the last one is going to be what? Negative 5, right, all squared, plus 2, that's going to be negative 5, then minus 15, right? When you pass that into the calculator, all three of them, the first one, you're going to get 65. The second one, you're going to get negative 15, sorry. And the last one, you're going to get a positive 20. Here, what matters is only the sign. We see that the first one is a positive 65, the second one is a negative, and the last one is a positive. Then we know the fact that for negative 10, it's within this range, so we're going to put positives there, right? Then from negative 5, we picked 0, so we're going to put negatives, because the answer when we put it in was a negative value. Then here's going to be positives, because for negative 5, not negative 5, positive 5, I made a mistake. Positive 5, we're going to get positives, right? Yes. Then now, remember the fact that we wanted to know which sign we need to look for, whether it's a positive or negative. So this is where it comes in. Do you see the fact that we need to look for positive, right? So you're going to go to your table and highlight the positive. So we see the fact that it's here and it's here, right? So our graph, what you got is our inequality exists there. So now we need to write our answer, right? To write our answer, remember the fact that the last step was to check whether is it greater than or greater than equals to know whether do we need to use brackets or do we need to use the curved bracket. And we see the fact that since it's just greater than, we need to use curved bracket, right? And just one more thing to indicate, whether we use square or curve, for positive infinity and negative infinity is always going to be curve, right? So with that said, now we're going to write our final answer. We always start from negative, right, going to positive. So we see the fact that our range, the one that we highlighted, is from negative infinity till what? Till negative 5. And it's from 3 till positive infinity. So we know the fact that here is from negative infinity till negative 10, curve bracket, because of it's just greater than, right? Then here it's what? It's from 3, right, till positive infinity, curve bracket, and this 3 gets the curve because of this one. But the negative infinity and positive infinity always gets the curve. I hope that makes sense, right? So now to write our final answer, you're going to take this 2 that you just wrote there. So you're going to say x is an element, then substitute this one that starts from negative infinity, right? And you're going to say negative 10, not negative 10, negative 5. Why did I say 10? Because the critical value is 5, not 10. So you're going to say negative 5. Sorry about that, right? So it's going to be 5, right? So it's going to be 4, 5, then curve bracket. Then you're going to see, because there's another part, which is going to be from 3 till positive infinity. And this is how your final answer is going to look. I hope that makes sense. Now taking the same question, but now we're going to say greater than or equals to, right? So again, I'm going to take my highlights and we're going to go to this diagram, right? And we're going to ask ourselves, is it in standard form? And we're going to say, yes, it is in standard form. And which one is it? Is the greater than and equals to. So it's going to be this one, the last one, going to be the greater than and equals to, right? Then you're going to ask yourself, which one are we looking for? Are we looking for positive and negatives? And we see the fact that we're looking for positive because of it's greater than and equals to, which is this one. So we're going to go in this direction, right? So now we're going to ask ourselves, is it just greater than or it's just greater than and equals to? And it's going to be this one, meaning our answer is going to be like this, right? So now we're done treating the diagram. Now we can basically solve the equation. So what I'm going to do is that everything that we have done here, do you see the fact that the steps, everything, this entire steps are going to be the same, right? Only how you write your final answer is going to change. So what I'm going to do is that I'm going to rewrite this whole thing, right? And then we're going to discuss the final answer. So let me just do that. Okay, so with that said, we know the fact that this is how it's going to look. And remember to get our signs as basically substituted, which is I'm not going to do because of it's exactly the same thing that we did in example 1, right? So now looking at the number line, remember the fact that we're looking for positives. So our positives is still going to be this region till this region, right? Then we're going to write those 2 regions, right? So we know the fact that from negative infinity till here, we only start from the left-hand side. The negative infinity always gets what? A curved bracket. The negative 5, since this is greater than and equals to, is going to get a square, right? Then this section is going to be a square, then it's going to be 3 till positive infinity, that one gets a curve, right? Regardless of whether it's a positive, regardless whether it's a greater than and equals to, the negative infinity and positive infinity always gets what? Always gets curves. So to write the final answer for this one is going to be x is an element from negative infinity till negative 5 square bracket, or it's going to be square bracket 3 till positive infinity curve bracket. Do you see the fact that this answer and this answer, this answer and this answer are the same thing? The only difference is that this one at negative 5 and 3, it's curve bracket, but this one is square bracket. So that's how you would solve this question, right? I hope that makes sense. So now we're going to do example 3, right? So it's exactly the same equation as number 1 and number 2, but the only thing that changes is the inequality. So with me saying that is that the steps, do you see the fact that how to do the number line? It's going to be the same thing. So it's going to be this method. You're going to use exactly this method and you're going to arrive into the same number line, right? So that is why I didn't show the calculations, because it's the same as the one that we did in number 1. I hope that makes sense, right? So now with that said, right, is that we need to basically answer the questions in the diagram. First question, is this in standard form? We see the fact that yes, it is. So we're going to go in this direction because it is in standard form. Then we're going to take which one it is. Do you see the fact that is the first one, right? So that's sorted, right? And now we need to check which signs do we need to look for. We need to look for either positive or negative, right? So we see the fact that it looks like the one here, exactly like the one here, right? Meaning we're going to go this direction, meaning we're going to be looking for negatives, right? So with that said, let's highlight it. We're going to look for negatives, so we're going to look for negatives. Then the next question is that since we're looking for negatives, how does it look? Is it just greater than and equals to or greater than? We see the fact that it's just greater than, so we're going to go in this direction, right? So we're going to go in this direction, so meaning we're going to use the curved bracket, right? So with that said, now let's write this section, this going from the left-hand side going to the right-hand side. So it's curved bracket, so this is the same as -5 is to 3. So our answer here is going to be x is an element. That's going to be -5 is to 3. And that's your final answer for this question. I hope that makes sense. Then now moving to example 4, same question as number 1 and number 2. So that is why I didn't show this calculations, because it's going to be the same thing, because the thing that we need to arrive at is the number line. I hope that makes sense, right? So since now we have the number line, we're going to ask ourselves the following questions. Is this in standard form? Yes, it is, right? So since it's in standard form, we're going to go in this direction, right? Then we're going to indicate which one it looks like. It looks like the second one. So that's sorted, right? So since it looks like the second one, do you see the fact that the second one is this one exactly? So meaning it's going to be, we're going to be looking for negative signs. So we're going to go in this direction, right? So we're going to go in this direction. Now you're going to ask yourself, is it greater or greater than and equals to? We see the fact that it's this one. So we're going to go in that direction, right? So we're going to go in this direction. So we're going to end here, right? So now we know the fact that our answer needs to be a square bracket. So our answer is going to be -5. Starting from the left-hand side is 2, 3, right? Square bracket. So our answer here is going to be x is an element between -5 and 3, right? And square bracket. And remember the fact that we're looking for negatives. That's why it's this. So I hope that makes sense. So now let's do the question, right? This question is example 5 where we have our x as negative. We never ever want to deal with negative x's, right? So if here they ask you, is this in standard form? Your answer is going to be what? Your answer is going to be no. So you're going to go in this direction, right? So it's going to be no. And the reason why I'm saying no, because I don't want a negative a, right? I need my a to be positive, right? Because it makes things simple. So now, since we know the fact that it's a, we need to write it in standard form. So the easiest way is to take everything to the other side so that it becomes positive. So this is going to be the same as this side is going to be 0. Then it's going to be, is going to be greater than, looking like this. Then take everything to the other side. Since it's negative, it's going to become positive. This one's going to become negative. And this one is going to become positive, right? So this is how it's going to look. And this looks like one of our standard form. So we know the fact that we have written it in this form, right? And now we need to tick off which one it looks like. Remember the fact that the inequality is eating the 0. So let's see which one is eating the 0 and it doesn't have the equals to. Eating the 0, do you see the fact that it's this one? With ax squared plus bx plus c is greater than 0. And I know the fact that this is a little bit small, but this first one is exactly like this. It's not written the same, like you could call this. It's not written like this, but do you see the fact that it's eating the 0? So it's exactly this one, right? So we know the fact that we sorted with that, meaning we're going to go back to answering yes now, right? Because we already have it in standard form, right? So now before we do the sign, what we're going to do is that we're going to factorize this and basically find our critical value and create the number line before we go to the last part of it, right? So let's do that. So when we factorize it, it's going to be 0, 8 greater than. Then when we factorize this, we're going to have the following. We're going to have it as x minus 3. Then this is going to be x minus 4. Then our critical value, equate each bracket by 0. So it's going to be critical value indicated. Then it's going to be x minus 3, right? Is equals to 0. Then you're going to say all x minus 4 is equals to 0. So this is the same as x is equals to positive 3. And this is going to be all x is equals to positive 4, right? Then you're going to have your number line. Then you're going to have 3 here, and you're going to have 4 here, right? Then you're going to draw dotted lines, right? Then you're going to have negative infinity, then you're going to have positive infinity, right? Then now, what we need to do is that we need to pick a number between negative infinity and 3, right? So when we pick a number between negative infinity and 3, I'm going to pick 1 here, right? Then we're going to pick a number between 3 and 4, which I'm going to pick 3,5, because that's a number that's between them. Then I'm going to pick a number between 4 and positive infinity, and I'm going to pick 6. You can pick any number that's between this range, right? So this is the number that I picked. Then what I need to do is that I'm going to take the one that I changed into and being a positive a. I'm going to use that to basically substitute these numbers. So that's going to be x squared minus 7x. Always remember, I picked this one. Really important, right? I picked this one that I changed into being a positive a. So it's going to be x squared minus 7 plus 12. Right, so let's substitute. So it's going to be what? It's going to be 1 all squared minus 7. Then it's going to be 1 plus 12. Then the second one is going to be 3,5 all squared minus 7. That's going to be 3,5. Right, and it's going to be what? Plus 12. Then this is equals to. And the last one is going to be 6 all squared, right, minus 7. Then this is going to be 6. Then this is going to be plus 12, right? Then equals to. When you pass this into the calculator for the first one, you're going to get 6. The second one, you're going to get negative 1 over 4. Then the third one, you're going to get 6. I said what's important is only the signs. So this one is going to be positive. This one's going to be negative. And this one's going to be positive. So for the one that we substituted 1, right, we got a positive 6. So here's going to be positive signs, right? For the one that we substituted, 3,5, we got negative. So we're going to substitute negatives here. Then the one that we substituted 6, we got a positive 6. So here's going to be positives, right? So now we have our number line sorted. Now we ask ourselves, which sign are we looking for? Are we looking for positive or negative? So we see the fact that this one, as we ticked it off, looks exactly like this one, meaning we're looking for negative signs, right? So we're going in this direction because the ones that we ticked are exactly the same way, right? So we're looking for negatives. So when we're looking for negatives, I'm going to highlight the section, right? Which is this one, right? Then we're going to check which bracket do we need to use. Do we need to use the curved bracket or the square bracket? We see the fact that it's just greater than. So we going to use the curved bracket. So we're going to go in this direction. So we're going to use this, right? So now, writing down the section that we highlighted is the same as saying 3, starting from the left-hand side, is 2, 4. So now our final answer is basically x is an element, then it's going to be between 3 and 4. So this will be your final answer for this question. So now we're going to do example 6. Again, we ask ourselves, is this in standard form? No, it's not in standard form. Remember that standard form needs to be ax, right? Plus bx plus c, right? Then some inequality, right? So we know the fact that it's going to be no. So we're going to go down. We're going to say no. Then now let's write it in standard form. Remember that we want our a to be always what? Positive. So I'm just going to leave the a this side and take everything to one side, right? So it's going to be ax squared. Then it's going to be minus x. Then this is going to be plus 18. And this is going to be greater than 0, right? Then now we wrote it in standard form. And which standard form is going to be this one, right? So now we know the fact that it's in standard form and it's that one. So we're going to say, now we move to saying yes. And again, I'm going to take off that standard form, which is this one, right? So now, before I indicate which sign do I need, what I'm going to do is that I'm going to factorize this, right? So when I factorize it, I have the following. It's going to be x minus 3. Then it's going to be what? It's going to be x minus 6 is greater than 0. Remember, why do we factorize? We need the critical value to create the number line, right? So our critical values it's going to be x minus 3 is equals to 0, or it's going to be x minus 6 is equals to 0. So this is the same as x is equals to positive 3, right? Or x is equals to positive 6. Create the number line. So it's going to be the number line like this, right? And this is going to be 3, and this is going to be 6. And this is going to be negative infinity, and this is going to be positive infinity, right? Then I'm just going to draw dotted lines like this. Then you're going to pick a number between negative infinity and 3. And the number that I'm going to pick is that I'm going to pick 1, right? Then you're going to pick a number between 3 and 6, which I'm going to pick as being 5. Then you're going to pick a number between 6 and positive infinity, and I'm going to pick 8, right? Then this one, the one that you wrote in a standard form, is going to be where you're going to substitute your numbers that you picked, right? So which one is this one? So it's going to be x squared minus 9, right? X plus 18. So we're going to substitute here, right? The numbers that we picked. So the first one is 1 squared minus 9. Then it's going to be 1 plus 18, right? Is equals to. The second one is 5 all squared minus 9. That's going to be 5. That's going to be plus 18 is equals to. And the last one is going to be 8 squared minus 9. Then it's going to be 8 plus 18. Then it's going to be equals to, right? Then we're going to get here. The first one is going to be 10. The second one is going to be negative 2. And the last one is going to be 10, right? What matters is the sign. So the first one is positive. The second one is negative. And the third one is positive. So let's write the signs, right? Here where we picked 1 is going to be positives, because when we substituted it, we get positive number. Then the second one is going to be negatives, like this. And the third one is going to be positive, like this, right? Then we sorted. So now we have our number 9 indicating the signs. So now we need to check which sign are we looking for. Are we looking for a positive or a negative? So let's see. Looking at the one that we wrote in the standard form, we know the fact that it looks exactly like what? It looks exactly like this one. So meaning we're looking for positives. Do you see that? We're looking for positives. So we're going in this direction. So we're going to highlight the positive signs, right? So we're looking for positives, right? Which is nice. So now we know the fact that we're looking for positives. But one more thing to write our final answer is that we need to know whether we're going to use curved bracket or square bracket. So we see the fact that it's not equals to, so we're going to use curved bracket. So this way, right? We're going to use curved bracket. So we know the fact that we're going to use curved bracket. So now writing our solution, we know the fact that it needs to go from negative infinity till 3, then from 6 till positive infinity. So here writing this region, and I'm just going to do it here, it's going to be negative infinity, and it's going to be 3 curved bracket, and this region is going to be 6 till positive infinity curved bracket, right? So taking this 2 as our answer is going to be x is an element, then it's going to be negative infinity till 3, or it's going to be from 6 till positive infinity. And that's your final answer for this question. So now we're going to solve what you call simultaneous equations. And here in grade 11, simultaneous equations is basically going to involve some quadratic equation too, right? So one is going to be a linear equation and the other one's going to be a quadratic, or it's going to be a linear and with any other type of equation. So here the first one is going to be that our first equation is a linear equation and the second one is a quadratic, and we need to solve for x and y, right? So now using that is that we always make the one that is a linear equation, equation 1, right? So in our case, we're going to say what? We're going to say y, right, minus 2x equals to negative 4. We're going to name it equation 1 because that's going to be linear. So this one is the linear, right? And this is quadratic. So we always make the one that's linear equation 1, right? Then we're going to take the quadratic or any other equation. We're going to make it equation 2. So it's going to be x squared minus y is equals to 4. And that's going to be equation 2, right? The reason why I'm making the linear one equation 2 is because of we're going to take the linear one, right, and create equation 3. So that's what we're going to do. So you're going to say taking taking 1, right? So you're going to have what? It's going to be y minus 2x, right, is equals to negative 4, right? Then you're going to make what? You're going to make your y, right, or your x the subject, but the easiest one is y. So it's going to be y is equals to, take the negative 2x to the other side. So it's going to be negative 4, right, plus 2x. Let me just fix it up. So it's going to be the same as 2x is what? Is negative 4. And this, we're going to call it equation 3, right? So this, we're going to call it equation 3. So after doing that, we already made the linear one into being what? Equation 3. We're going to take equation 3 and substitute it to the one that we did not change, which is equation 2, right? So you're going to substitute 3 into 2, right? So that's what we're going to do. So it's going to be x squared, right, plus y is equals to 4. So now wherever I see y, right, so wherever I see y, I'm going to substitute by this part that I just highlighted, right? So that's what we're going to do. So it's going to be x squared plus, open bracket, you're going to have 2x minus 4 is going to be equals to 0, right? So to see the fact that you're doing the right thing, everything needs to be in one term. So there shouldn't be two variables, right? You see the fact that we only have one variable, which is what? Which is just, which is just x, right? So let me just clean it up, get rid of the bracket. So this is going to be the same as x squared plus 2x, right, minus 4. And this is going to be equals to 0. Do you see the fact that this is in standard form? So that means the fact that what? I can actually factorize. So when I factorize, I'm going to have two brackets. So it's going to be x plus 4, right? And this is going to be x minus 2 is equals to 0. Then this is going to be x plus 4 is equals to 0. Or it's going to be x minus 2 is equals to 0. So x is going to be equals to what? To negative 4 here. Or x is going to be equals to positive 2. So now we have x, right? So we have solved the x. But remember, we're solving x and y. So what we're going to do is that we're going to substitute both our x into equation what? Into equation 3, because it's already in terms of y, right? So that's what we're going to do. So we're going to substitute x equals to negative 4 and x equals to 2 into what? Into 3, right? So now we're going to do that. So it's going to be y here is equals to what? Is equals to 2x, right, minus 4. Then y is going to be equals to, I'm going to substitute by negative 4. So it's going to be 2 negative 4, right, minus 4. And therefore y is going to be equals to negative 12, right? And this side is going to be y is equals to 2x minus 4. We're going to substitute by 2 now. So it's going to be y is equals to 2. Then it's going to be 2 here minus 4. Therefore, y is equals to what? Is equals to 0, right? So your x and y's are going to be the following. So your answers are going to be the following. It's going to be this one and this one and this one and this one. So you have solved your x and y. So now we're going to do example 2. As I said, the fact that you first need to pick out which one is what, which one is the linear function, right? So here we see the fact that our linear function is this one, right? So this is going to be our linear function. So this is going to be the linear function. No matter what the other one is, we really don't care. What matters is that we need to first pick out the linear function, because the linear function is the one that we're going to change to create equation 3, right? So now we're going to take the linear function and we're going to name it equation 1. So you're going to say x plus 1 is equals to 2x. And this is going to be what? This is going to be named equation 1, right? Then you're going to say x is equals to 5 divided by x minus 2, and this is going to be named equation 2. Regardless on how the second equation looks, don't be scared of it. Just use the same rules that we used when we were doing example 1, right? So now you know the fact that you have equation 1, you have equation 2. What do? We take equation 1 and transform it to create equation 2. So that's what equation 3, sorry. So we're going to say taking, right, 1. So it's going to be y is equals to what? Y plus 1 is equals to 2x, right? Take the 1 to the other side because I want this y alone. So it's going to be y is equals to 2x, right, minus 1. So now this is going to create what? This is going to create our equation 3. So now what we're going to do is we're going to take equation 3 and substitute it into equation 2. So that's what we're going to do, right? So we're going to say substitute equation 3 into what? Into 2. And again, the reason why we're substituting into equation 2, because equation 2 is the one that we did not change. Think about it, it does not make logical sense for us to substitute equation 3 into the one that we changed to make equation 3, which is equation 1, right? It really doesn't make sense. That's why we substituted into equation 2, right? So now, what we're going to do, we're going to substitute equation 3 into equation 2. So now, whatever I'm just highlighting right now, wherever I see where I'm going to substitute by that, right? So now let's write equation 1. Let's write equation 2. So we know the fact that equation 2 is y is equals to 5 divided by what? Divided by x minus 2, right? As I said, wherever I see y, I'm going to substitute by the green part. So this is going to be the same as 2x minus 1 is equals to 5 divided by what? Divided by x minus 2. Do you see the fact that I can change this expression and divide it by 1 like this, right? And since it's like this, since it's a fraction, I can do what? I can cross multiply. So that's what I'm going to do. So I'm going to cross multiply. So I'm going to take this section and I'm going to take this one and multiply by this one. So let me just highlight and show you what I'm saying. So let's change color. So I mean the fact that I'm going to multiply this one and this one together, right? And I'm also going to multiply this one by 5 together. So that's what I'm doing, right? I'm going to multiply the orange or yellow one. So it's going to be 2x minus 1, right? And here it's going to be x minus 2 is equals to 1 multiplied by 5, which is going to give you 5, right? So now you see the fact that this is going to form kind of like a quadratic function, right? But our problem is that it's not in the standard form. If it was just 0 here, it was perfect. We were just going to equate by 0 and just solve for x. But it's not. So what do we need to do? We need to first expand this side so we can create a quadratic function so we can factorize it, right? So that's what we're going to do. So now let's expand that side. So when you expand it, you're going to have the following. You're going to have that this is going to be 2x squared minus 5x. Then it's going to be plus 2 is equals to what? Is equals to 5, right? So now we're going to take the 5 to the other side. So this is going to be the same as what? As 2x squared minus 5x plus 2 minus 5 is equals to 0. So you're going to say what? You're going to say 2 minus 5 is going to give you negative 3. So it's going to be negative 2x squared, right? Minus 5x. And it's going to be minus 3 is equals to 0. So now we can do what? We can basically factorize this. So this is going to be 2x, right? Then this is going to be plus 1. Then here is going to be x minus 3. And this is going to be equals to 0. So this is the same as 2x plus 1 is equals to 0. Or it's going to be x minus 3 is equals to 0, right? So now we're going to solve for x. It's the same as 2x. Take the 1 to the other side. It's going to be negative 1. And this side is going to be divided by both sides by 2. So it's going to be x is equals to negative 1 over 2. With this side is going to be x is equals to positive 3. So you have your x is going to be equals to negative a half, and the other one is going to be what? Equals to 3, right? So now what we're going to do is that we're going to substitute. So we're going to substitute x equals to negative 1 over 2 and x equals to 3 into what? Into equation 3. So into equation 3, right? So we're going to say y here is equals to what? Y is equals to 2, right? Open bracket. So it's going to be x minus 1. So it's going to be y is equals to what? It's going to be equals to 2. That's going to be negative a half, right? Minus 1. So you're going to say 2, right? Multiplied by negative a half, right? Minus 1 is going to give you what? It's going to give you negative 2. So therefore, y here is going to be equals to negative 2, right? Then this side, it's going to be y is equals to 2. X minus 1, right? So it's going to be y is equals to what? Is equals to 2. Then it's going to be 3, right? 3 minus 1. Therefore, y is going to be equals to what? When you say 2, right, multiplied by 3 minus 1, you're going to get your answers being 5. So y here is going to be equals to 5. So your final answers are going to be the following. I'm just going to highlight them. So your final answers are going to be, not my pen. So your final answers are going to be this one. Let me just change my color. It's going to be this one. X is equals to half. and x is equals to 3, also y is equals to negative 2, and y is equals to positive 5. So this would be your final answer for this question. So now we're going to move to nature of roots, right? So with nature of roots, this is the idea that you need to understand. Let me just give you the formula of delta, right? Or this triangle, which is going to be b squared minus 4ac, right? And if you look closely, before I discuss everything, if you look closely, this is from the quadratic, right? This delta is from the quadratic, which is going to be what? We know the fact that this is negative b, right? Plus or minus, then it's going to be negative square root, then it's going to be b squared minus 4ac, right? Divided by 2x. Do you see the fact that this triangle is from where? It's from actually the quadratic. It's the same thing, right? So now we need to discuss what each thing means, right? So if they say the fact that determine when there's no roots, right? You always, when they talk about roots, right, solution, always think about or determine a k value of something, right? Always think about the nature of roots, right? So here, when they say the fact that there is no roots, right, it means the fact that your delta is what is less than 0. So do you see the fact that it's going to be less than 0, right? What does less than 0 mean, right? It means the fact that it's actually negative, right? Our triangle, when we substitute the values, it gives us a negative, right? And it makes sense why they say there is no root, because of if you put a negative inside a root, what does it give you? It gives you undefined. So if your delta is negative, which is less than 0, then this is where there is no root or non-real roots, right? Then now we move to another side of the branch. And remember the fact that we're going to have, when it's less than, then we're going to have the other opposite side where it's greater than and equals to, right? So this one is when there's real roots, right? And this is considered when it's greater than and equals to, right? But that is going to be divided into two parts, which is when it's just greater than, right? Meaning the fact that the roots are unequal. And we're going to go back to the diagram and talk about when it's equal and unequal. Then when it's equal, meaning it's equals to 0. So if you find your delta, the fact that it's equals to 0, meaning that there is equal roots, right? Then under unequal, we have when it's what? When it's a rational root, and we have when it's an irrational root, right? So that's how you will trickle down the diagram, right? So now with that said, right? With that said, let's understand what do we mean when they say there's no roots, when there is a real root and they're equal, and when there is unequal roots. Let's understand it from a diagram point of view, right? So when they say there's no roots, do you see the fact that in our diagram there is no y-intercept? So it means the fact that our graph does not have any y-intercept. That's what it means to have no roots, right? When they say the fact that it's an equal root, right, it means the fact that our turning point, right, and the x-intercept, right, is the same point, right? That's when our roots are going to be equal. So our turning point and our x-intercept is the same root. Then when we say the fact that the roots are unequal, this is what it means, right? We can be rational or irrational. So this is what it means, right? It means the fact that we basically have two roots, right? Now, they don't have a diagram here. I don't have a diagram where it talks about equal roots. So when it talks about when it's rational, I just have it when it's irrational, right? So when it's rational, right, and they say the square is that you will get, sometimes you have a graph where it looks like this, right? And here we have a point -2, and here we have a point 2. This is called what? This is called when the roots are rational, right? Irrational means the fact that it's going to be like this, right? Maybe the other one is at -1 and the other one is at 3. Since these roots are not what? Are different numbers. Like, do you see the fact that here it's the same number but different sign? Here it's different numbers. This is going to be considered unequal, and this is going to be considered irrational. So let me just say it. This is considered irrational. It's unequal and irrational, and this one is going to be considered rational. I hope that made sense, right? So that's the gist on nature of roots. So now let's do a question, right, that contains the nature of root, right? It says f of x is equals to x squared minus 5x plus c, right? And it says determine the value here. It says determine the value of c if it's given that the solution is, or when f of x is equals to 0, meaning we're finding the x-intercept. Because if you look closely, is that we've been talking about the x-intercept, right? Is that when f of x is equals to 0, meaning we're looking for the f of x, and this is what's happening, right? And we need to determine the value of c. So we need to relate this true, right? So we see the fact that this is what? This is actually the quadratic formula in numbers. So this is the quadratic formula, right? In a number form, right? They already substituted everything and simplified everything, right? So what do we know? We know the fact that delta is the one that's inside the bracket, right? That's inside the square root, right? So we know the fact that delta is going to be equals to 41, right? Now, since we know the fact that this is equals to 41, I can change this in terms of what? In terms of the triangle. So we know the fact that the triangle is equals to b squared minus 4ac, right? From here, we know the fact that a is equals to 1. We know the fact that b is going to be equals to what? It's going to be equals to negative 5. And c is going to be equals to just c. And that's the value that we want, the unknown, right? So we know the fact that the triangle is going to be equals to what? To negative b squared minus 4. Then this is going to be what? This is going to be 1. And this is going to be c. So this is going to be the same as the triangle is going to be equals to 25 minus 4c, right? But we already know that this is equals to 41. So this is the same as 41 is equals to 25, right? Minus what? Minus 4c, right? Take the 25 to the other side. So it's going to be 41 minus 25, which is going to give me 16. So this is the same as 16 is equals to what? To negative 4c. Divide both sides by negative 4. So it's going to be 16 divided by negative 4, which will give me negative 4, right? So it's going to be negative 4 is equals to c. So c here is going to be equals to negative 4, right? So that's how you would solve for c. Remember the fact that here we just use this relationship of the quadratic formula, that we know the fact that the triangle inside is basically equals to what? To this one, right? It's equals to the delta. I hope that made sense. So now let's do example 2, right? It says for which values of k will the equation x squared plus x equals to k have no roots. So what are we looking for? Where is no roots? No roots is this one, right? So we're looking for when delta is less than what? So we're looking for when this one situation is happening. So here we're looking for what? We're looking for when delta, right, is less than 0, right? So now we need the triangle. So we know that the triangle is equals to what? To b squared minus 4ac, right? But first we need to write this in a form of ax squared plus bx plus c is equals to 0, so that we can substitute a, b, and c. So let's do that. So it's going to be x squared plus x, take the k to the other side, so it's going to be minus k is equals to 0, right? So here a is going to be equals to 1, b is going to be equals to 1, and c is going to be equals to negative k. So let's substitute. So it's going to be the triangle is equals to what? To 1 all squared minus 4. Then it's going to be what? It's going to be 1. Then it's going to be negative k, right? So this is the same as the triangle is equals to 1. Then this is going to be what? 4, negative 4 multiplied by 1. So it's going to be negative 4. Then it's going to be negative k. Then the triangle is going to be equals to 1 minus, and the minus is going to give us a positive, so it's going to be plus 4k, right? So now we know the fact that this triangle is equals to that. So let's substitute it. So it's going to be delta is equals to 0. So it's going to be 1 plus 4k, right? Is what is less than 0. So take the 1 to the other side. So it's going to be 4k is less than negative 1. Divide both sides by 4. So it's going to be k is less than 1 by negative 1 over 4. And that's going to be your k value when you have no real roots, right? So that's how you would answer this question. So now we're going to start with exponential, right? So the first thing that we're going to do is we're going to basically ask ourselves, what is an exponential, right? So in exponential, I have a couple of examples, right? Is the following. So let me just, before we get into the example, is that I just want to explain it in like basic terms. What is it, right? So let me just change my pen. So in basic terms, before looking at example, if we have x, right, which is x is going to be the base, right, and is to the power n, right, and this n is called what? It's called the power, right, or it's called what? It's also called an exponential. So exponential and power is the same thing, right? So exponential, right? So this x is a base and this is what? Is to the power of something, right? So this, when you rewrite it, is the same as multiplying x n times. So this is the same as saying x multiplied by x multiplied by x multiplied by x multiplied by x, right? Till what? Till n times. So we are multiplying x, so we are multiplying x n times, right? So we are multiplying x, right, n times. So n times, right? So meaning this position could be the nth position. Could be the nth position. Hope that makes sense, right? So we're multiplying x n times when x is what? When n is a natural number. What does it mean, remember? When n is a natural number, what does it mean? It means that our power can only be natural numbers. What are natural numbers? Are 1, 2, 3, 4, 5, all our counting numbers. So that's what it means, right? So before we just get in again, this is going to be the same as, this is talking about in a general form, right? This basically, if I give you x to the power 2, right? This is what? This is basically x multiplied by x, right? So the n here is 2, and this is how you would express it, right? So now with that said, let's look at our example, right? So I'm just going to change my pen. So looking at the example, number 1, right? It says we have a multiplied by a multiplied by a. What does that mean, right? In simple terms, this is basically equals to how many a's are multiplied with each other is 1, 2, 3. So it's 3a. So this is going to be the same as a to the power 3, right? And 3 is going to be our power and a is going to be our base. I hope that makes sense, right? So the second one, it's x plus 1, right, in a bracket, multiplied by the same as x plus 1, multiplied by x plus 1, multiplied by x plus 1. How many brackets are there that contains x plus 1? It's 1, 2, 3, 4. So this is the same as what? It's going to be the same as x plus 1 to the power 4. Our base here is going to be this x plus 1. So this is going to be our base. And 4 is going to be our power of, or our what? Or our exponential, right? Then the last one, it says 2 multiplied by 2 is the same as what? How many 2's are there multiplying each other? It's 2 of them. So this is going to be the same as 2 to the power 2, right? Where 2, this 2 here, right, is our base. And also our exponential is 2, right? I hope that makes sense. So now we're going to do exponential law, right? So with exponential laws, these are the different laws, right? So these are the laws. So what I'm going to do is that when I answer questions, I'm going to have the laws on the side, right? So these are the different laws when we, when you're multiplying. So before I just go into the first example, let's just discuss the laws, right? Is that when you're multiplying two, exponential, and they have the same base. Here we're dealing with same base, right? We can add the exponential. If the bases are the same and you're dividing, we can subtract. Do you see that? We can subtract the exponential. If you have two numbers, right, but they are both to a power of one number, you can distribute the exponential. And same applies if you're dividing two numbers and they're into a power of something, you can distribute the exponential. If you have a one number that's in the power, then again into another power, if you put it inside another bracket, is that you can actually multiply. Do you see that? Multiply the exponential. Then 1 divided by a number, right, is the same as the number to the power negative something or whatever variable. It could be a number or a variable. Then anything, this is anything, could be a number, could be a variable. Anything to the power 0 is always going to be equals to 1. I hope that makes sense, right? So now applying the first law, right? So before we start, let me just change my pen, right? Is that, remember with the first law, what does it say? It says that our bases need to be the same. Both the terms need to be multiplying each other. And if that's the case, what do we need to do? We need to add the exponential, right? So to do number 1, what do we see? We see the fact that our base is the same as x. So it's going to be x, right? So we can add the exponential. So this is going to be 5 plus 3, right? So when you say 5 plus 3, what's going to give you? It's going to give you x to the power 8. So that's how you would answer the first question, right? So the second one, right, is that your base needs to be the same. Do you see the fact that we have 2 here and we have 2, meaning our bases are the same? Then what can we do? Both the terms are multiplying, so we can what? We can add the exponential. So this is going to be 2, right, which is our base. Then this is going to be 3, right, plus what? Plus negative 2, right? And this is going to give us what? If you say 2, if you say 3 minus 2, it's going to give you what? It's going to give you positive 1, which anything to the power 1 is basically its number itself, right? I hope that made sense. So now moving on to example number 3, right? Remember the fact that base is the same, multiplying, then we add the exponential, right? So here we have 2. Do you see the bases are the same? It's 2, 2, 2, right? And here, meaning, and they have all the terms are multiplying, meaning we can add the exponential. But remember the fact that this is the same as to the power 1, and this one is the same as to the power 1, right? So this is going to be the same as 2, then is to the power 1, then we're going to add. So it's going to be 1 plus 3x plus 2, right? And this is going to be equals to what? Group like terms, which is going to be 1 and 2. So this is going to be the same as 2 to the power 3x, right? Plus 3. And this is how you would solve this question. So now we're going to do what? We're going to apply law 2, right? Law 2 is dealing with division, right? It says if the bases are the same, right? And we are dividing, what can we do? We can subtract the what? We can subtract our exponential, right? So the first one, we see the fact that we have number 1, we see the fact that our base is the same as x, right? And we are dividing, right? If it's a fraction or it's an actual division, it means the fact that we're dividing, right? So what can we do? We can technically what? Subtract the exponential. This is the same to the power 1, right? So this is going to be 5 minus 1, which is going to be the same as what? This is going to be the same as x. Then 5 minus 1 is going to give you 4, so it's going to be to the power 4, right? So number 2, right? We see the fact that our bases are the same and we're dividing, right? So meaning we can subtract the exponential. So this is going to be 2 because 2 is our base. Then it's going to be 3 minus 5, right? Which is going to give us what? It's going to be 2 to the power negative 2, right? So now doing number 3, right? So doing number 3. So the first thing that you need to do is that you need to basically divide the numbers, right? So it's going to be the same as saying 12, right? So let's just do that first. So if you say 12, right, divided by negative 4, what are you going to get? You're going to get negative 3. So instead of writing 12 divided by 4, you can replace that 12 divided by negative 4 by what? By negative 3. So that are the numbers sorted, right? So now what we're going to do is we're going to look at the numerator and denominator first, right? And check the fact that can we group, can we add, can we add the exponential now? We see the fact that in the numerator, we can't do that because we have a to the power 6 and we have b to the power 6. The bases are not the same. So I'm going to leave that the way it is. So it's going to be a to the power 6 and it's going to be b to the power 6. But what do I see? I see the fact that in the denominator, there is 2 a's, right? We have the same base. So I can apply what? I can apply the, the product rule, right? Meaning if we have 2 terms that have the same base, right? And we can add the exponential. So this is going to be the same as a, right? Same base. Remember, this is the base, and this is the same to the power 1. So this is going to be 1 plus negative 2, right? Put it in the bracket, and this is going to be multiplied by b to the power 3. Out, that makes sense, right? So now having this, right, is that what we're going to do now? We're going to do the following, right? Is that we're going to simplify this first. So it's going to be negative 3, then it's going to be a to the power 6, then it's going to be b to the power 6, right? And this is going to be divided by what? If you say 1 minus 2, you're going to get negative 1. So this is going to be the same as a to the power negative 1, and this is going to be b to the power what? To the power 3, right? So now do you see the fact that we only have one term that is to the power, we only have one term that has a base of a in the denominator, and we also have only one term with the base of b. So now what we can do is we can apply the division, right? So we know the fact that we're going to have negative 3. Then now we're going to just look at the a. So it's going to be a. Do you see the fact that it's the same base, right? And it's dividing. So what can I do is the following, is that I can say 6, right? Then say 6 minus what? Minus 1, right? Because we are subtracting because there's division. right? So that A is sorted. Then you're going to say this is multiplied by B, which is going to be 6, right, minus 3, right? And now let's simplify this. This is going to be the same as negative 3. If you say 6 minus 1, you're going to get what? You're going to get a positive 7. So this is the same as a to the power 7, right? And if you say 6 minus 3 is the same as 3, so there's going to be b to the power 3. And this is how you would solve this question. So now what we're going to do is we're going to apply law 4, right? Law 3, not 4, right? So I just wrote the law here so that you can see what we're doing, because we're going to be applying the law, right? It says if you have two terms, right, and both terms are inside a bracket, very important, both those terms are inside the bracket, then we have a power. What can we do? We can distribute the power in each term. So with number 1, right, it's going to be the same as what? We see the fact that we have what? We have 5a, right, to the power 2, then this is going to be 3. So we need to distribute the 3. So this is going to be the same as saying what? As saying, let me just, not highlighter, right? So this is going to be the same as saying 5, right, to the power 3, right? Then this is going to be a, which is going to be 2 multiplied by 3. Here, if you look at it, I actually also applied law number 5, right? So here, this part of saying 2 multiplied by 3, it's actually law number 5, right? So here, let's simplify this. So when we simplify it, it's going to be 5 to the power 3, which is I'm going to get 125. So my answer here is going to be 125. Then this is going to be 2 multiplied by 3, which is going to be a to the power 6, right? So remember the fact that this one, when I say 2 multiplied by 3, is actually law number 5, right? So with that said, right, let's do number 2. It says what? It says if I have the following, which is 2x to the power 2, right, y, then it's going to be 5, right? So now let's apply the law. So I need to distribute this exponential in each and every term, right? So it's going to be 2 to the power 5, right? It's going to be x, then it's going to be 2 multiplied by 5, then it's going to be y, then it's going to be to the power 5, right? Simplify this. This is going to be 2 to the power 5. It's going to give you what? It's going to give you 32, right? So then you're going to have x, then 2 multiplied by 5 is going to give you 10, then y is going to be to the power 5, right? So that's how you would do this question. Then now we're going to do number 3, right? So number 3 is like this. So if I have the following, if I have 2a to the power 6b, right, and to the power 3, then here I have 3a, right, 2, then b, 3, right, all squared. Then now I need to do this law, right? Distribute the exponential. So this is going to be, for the first one, it's going to be the same as what? And I'm going to put it inside a bracket, right? So this is going to be the same as having 2 to the power what? To the power 3, right? And it's going to be a, then it's going to be 6 multiplied by 3, right? Then it's going to be b to the power 3, right? The other bracket, this one is going to be the same as 3 to the power 2, right? And it's going to be a to the power 2 multiplied by 2. Then it's going to be b to the power what? 3 multiplied by 2, right? So now this is going to be equals to what? Let's simplify this. It's going to be 2 to the power 3, which is going to give me 8. So still going to put it inside the bracket. So it's going to be 8, right? Then this is going to be 6 multiplied by 3, which is going to be 18. So this is going to be a to the power 18. Then it's going to be b to the power 3. So that's sorted, right? Then here it's going to be what? It's going to be 3 to the power 2, which is going to give me 9, right? Then it's going to be what? It's going to be a to the power 4. Then the last one is going to be 3 multiplied by 2, which is going to be b to the power 6. So it's going to be b to the power 6. But we're not done, because do you see the following? Let me just take my highlighter. Do you see the fact that we have the same base of a here and a here? So we can add the exponential because everything is multiplying each other. And also, right, I have the same base of b, meaning I can add again the exponential. And the last thing what we can do is we can multiply the numbers together. So let's do that, right? So this is going to be equals to, when I say 8 multiplied by 9, what I'm going to get? 72. So this is going to be 72, right? Then now applying law 1, it's going to be a, right? Same base. Then it's going to be 18 plus 9, right? Then it's going to be B. Then it's going to be 3 plus 6, right? So let's simplify this. It's going to be 72. Then it's going to be A. If I say 18 plus 9, I'm going to get 27. So this is to the power 27. Then it's going to be B. If I say 3 plus 6, it's going to be what? It's going to be 9. So this is going to be 9, right? So that's how you would solve this question number 3, right? So now moving on to question number 4, right? So question number 4, right, it's actually the reverse of this law, right? So here in question number 4, they actually gave you this portion. They want you to change this into this. That's what's happening, right? So what do we see? We see the fact that we have a common what? We see the fact that we have a common exponential, right? Since we have a common exponential, that means I can multiply the exponential, right, together. Then that can be to the power what? To the power x. So 2 to the power x multiplied by 3 to the power x is the same if I had what? If I had 2 multiplied by 3, right, to the power x, which is when we simplify it. When I say 2 multiplied by 3, it's basically 6x. So that's how you would solve this question. So now let's do applying law number 4, right? So with law number 4, remember, let me just write it here on the side. Remember the law says what? If I have A divided by B to the power n is the same as having A to the power n divided by B to the power n. That's the same thing, right? So now using this question, now let's apply it. So it's going to be what? It's going to be me distributing the x in the numerator and denominator. But do you see the fact that in the numerator we have 3 and x? There's 2 terms multiplying each other. So if I take this, so it's going to be 3a divided by b to the power 2 on x, right? So this is going to be the same as what? Distribute the x in the numerator and denominator. So in the numerator, there's 2 terms. So that's going to be the same as 3 to the power x and a to the power x. And this is going to be divided by b to the power 2. Then we're going to say multiply by x. Remember the fact that this is what? This is actually law 5, right? And let me just write it down. Law 5 says the following. It says the fact that if I have a to the power what? To the power n, right? Multiplied by m, what do I do is that I multiply the exponential. So this is going to be the same as n multiplied by m. So that's what I'm doing here, right? So simplify this. This is going to be 3 to the power x, and this is going to be a to the power x, and this is going to be divided by b to the power 2x. And that's how you would solve this question. So now applying law number 5, right? So applying our law number 5, the one that we've been using in law number 3 and law number 4, right? So it says what? It says, let me just write it again on the side here. It says if I have a, right, to the power n and m here, then this is going to be the same as a to the power m multiplied by n, right? So n multiplied by m. So that's going to be the same thing. So using that law, we're going to apply it here, right? So my pen here. So if the first one, you see the fact that we have 5, right? Then it's going to be a to the power 2, then to the power 3. So this is going to be the same as what? This is going to be 5, right? Remember the fact that 5 is not inside the bracket, so it's not affected by this 3. If it was inside the bracket, it was going to be affected by this 3, but it's not, so it's not affected, right? So this is going to be a here to the power 2 multiplied by 3. So my final answer is going to be 5 to the power a to the power 6, right? So that's that. So now number 2, right? It says what? It says 27, right? And it's to the power 2 divided by 3, right? So if we have a number like 27, right? And it's going to be 2 divided by 3. Normally with this type of question, they're going to say without a use of a calculator, but we're going to like cheat and use the calculator. So I'm going to freeze the screen, right? And show you on the side on how we use the calculator to find the factors, right?
So what you're going to do is you're going to take your calculator, you're going to switch it on, obviously. Then you're going to press 27, right? Then after pressing 27, you're going to say equals to. Then after saying equals to, you're going to press shift. Then you're going to go here with the degrees. At the top, it has facts, right? So you're going to press that. Then it's going to change your number into factors, right? So that's how you will find factors using your Casio calculator.
So as I've shown you in the screen after freezing it, we know the fact that we can write 27 as what? As being 3 to the power 3, right? So that's going to be what? This is going to be, what did I say 7 here? This is 3. Let me just erase that. Did not see that. So this is 3, not 7, because in the equation is 3. So I just fixed that 7 that I wrote into a 3, right? As you've seen me showing in the calculator, I can change 27 into a factor, which is the same as 3 to the power 3, right? And this is still going to be to the power 2 divided by 3, right? So now we're going to apply the laws. So this is going to be equals to. So this is going to be the same as 3. Then this is going to be 3 multiplied by 2 divided by 3. Multiply this. So if you say 3 multiplied by what? By 2 divided by 3, you're going to get the fact that it's 2. So this is going to be the same as 3 to the power 2, right? So therefore, your answer is going to be what? It's going to be just 3 to the power 2. Or you can just simplify it. If you say 3 to the power 2, it's going to give you 9. So your final answer is 9 for this question, right? So now doing number 3, which is I'm going to do it here. It gives you the following. It's a to the power negative 3, right? Then it's going to be b to the power 1 over 3. Then it's going to be c. And that whole thing is to the power 3, right? Remember the fact that we distribute the exponential everywhere. So the first one is going to be a. Then it's going to be negative 3 multiplied by 3 using this law, right? Then this is going to be b to the power 1 over 3 multiplied by 3 using the law. Then it's going to be c to the power 3, right? Simplify this. This is going to be a to the power negative what? Negative 9, right? Then this is going to be b, right? And this is going to be to the power 1, which is, right? Then here's going to be c to the power 3. So b to the power 1 is the same as b. So your answer is a to the power negative 9. Then it's going to be b. Then it's going to be c to the power 3. And that's how you would do this question. So now we're going to do law number 6. I just want to say something. I think you've seen when we're doing like law number 1, law number 2, 3, or 4, as we're going on, is that as we're going further down, I'm still applying other laws. When I say law number 6, I don't mean that it's just law number 6 that I'm applying, right? I'm also applying other laws, right? Just to put it out there, right? So now with number 1, right, it says what? It says we have a to the power 2, right, multiplied by x squared divided by a cubed, then x, right? Do you see the fact that here we need to first apply what? We need to first apply the division law, right? Law number 2 first. So how do we apply that? It's going to be what? It's going to be a and a. So we see the fact that it's the same base. So it's going to be a to the power y to the power 2. Then you're going to say minus 3, right? Then here it's going to be what? It's going to be x, because there's another x here. This is the same as to the power 1. Then this is going to be 2, right? Minus 1, right? Simplify that. It's going to be the same as what? It's going to be the same as 2 minus 3, which is going to give me negative 1. So this is going to be a to the power negative 1. Then here it's going to be x to the power 1, right? So I'm going to leave it like that, right? So now with law number 6, we're basically changing negative exponential into positive. Do you see the fact that if I have x to the power any negative number, I take it down, right? So this is going to be the same as x here. Then this is going to be divided by what? Divided by a. And this will be your final answer, right? So now moving on to number 2, we're going to do the following. We have 3, right? So we have 3. Let me just rewrite this one. Let me just erase this. So it's going to be the same as 3, then x to the power 3, right? And this is going to be divided by what? Divided by 3x, and this is all squared. So first, let's deal with the denominator, right? So this is going to be the same as 3x cubed, right? And divided by what? By distribute the square. So it's going to be the same as 3 to the power 2. Then here it's going to be what? It's going to be x to the power 2, right? What do we see? We see the fact that the numerator and denominator have the same basis, right? So here, let's deal with 3 first. So this is going to be 3. This is the same as to the power 1. If we say 1 minus 2, right? Then for x, it's going to be 3, right? Minus 2. So let's simplify this. This is going to be the same as 3 to the power y to the power negative 1. And here it's going to be the same as 3 minus 2. It's going to be what? It's going to be the same as positive 1. So this is going to be the same as positive 1, which is I'm going to just write it in x, right? We want to get rid of the negative exponential. So our answer here is basically going to be x divided by 3. And this is how you would solve this type of question. So just to emphasize more on this law, they can also give you, and I'm going to just do it in a different color. if they give you something like this, maybe your final answer after solving, and they say they want positive exponential, right, is that if you get x maybe to the power 2, to rewrite this is going to be the same as 1 divided by x squared, right? So your power, if it goes down, it changes from being what? A negative to a positive. They can also give you like this. So if I have 1 divided by x to the power, maybe a negative, meaning a negative 3, this can be written as what? Since now it's in the denominator, it needs to go to the numerator. So this is the same as x to the power 3. Just wanted to emphasize those two things there. So now applying law number 7, it basically says that anything to the power 0 is equals to 1, right? So here we see for the first one, it says a to the power 0. What does that mean? That means that this is going to be equals to 1, right? So here the second one, we have an expression inside a bracket, and that is to the power 0. So again, anything, whether it's like 2 terms, 3 terms, if they're in a bracket, right, and they're into the power 0, that's still going to be equals to 1, right? Even here, since x squared plus 2x plus 1, they're all inside a bracket and they're all to the power 0. That means the fact that this is going to be equals to 1. So that's law number 7. So now what we're going to do is we're going to do simplifying exponential expression. So what that means in simple terms is that we're going to use our laws to basically simplify this expression it's in its most simplest term, right? So we're going to use it to simplify it into its most simplest term, right? So let's do this first example, right? It gives us what? It gives us 2 to the power 2n. Let me just change my pen. So it's going to be 2 to the power 2n multiplied by 4 to the power n multiplied by 2. Then it's going to be 16 to the power what? To the power n, right? So what do I see? I see the fact that I have 2's, right? And I have a 4 and 16. So what do you do when you have that? You're going to take this 4 and 16 and you're going to find the factors. As I showed you with the previous question, how to find factors using your calculator, you're going to do that, right? So you're going to change this 4, right, using your calculators to find the factors. Then you're going to change the 16 using your what? Your calculator to find the factors. So that's what we're going to do. So we see the fact that we're going to have the following. We're going to have 2 to the power 2n. Then this is going to be multiplied by this 4 is going to change to what? To 2, right? To the power 2, right? And this is going to be n, right? So everything that you change, right, into a factor, you put inside a bracket, then this is going to be multiplied by 2. And this whole thing is going to be divided by what? Divided by the 16. You're going to change it, which is going to be the same as 2 to the power 4. And this is going to be n. So do you see the fact that everything is in terms of 2? Meaning our base is the same, which is good, meaning that I can apply my 2 laws, right? My first law and my second law. But first, let's apply what? Let's apply law number 5. Do you see the fact that the 2, the one that I just changed, it's kind of wanting us to use law number 5. So that's what we're going to do. So we're going to say 2 to the power 2n, right, multiplied by, then when you say 2, then it's going to be 2 multiplied by n, then it's going to be 2. Then here in the denominator, it's going to be 2, then it's going to be 4 multiplied by n, right? So let's simplify that. We're going to have 2 to the power 2n multiplied by 2 to the power 2n. Then it's going to be multiplied by 2. Then this whole thing is going to be the same as 2 to the power 4n, right? So now everything is nice and everything is sorted. So the first thing that we're going to do in the numerator, because there's multiple terms, right? We don't want multiple terms, we just want one term, right? Is that we're going to use law number 1 because of DT, the fact that the bases are the same and everything is multiplying, so I can add the exponential. So let's do that. So this is going to be 2 to the power 2n, right? Add them, so it's going to be plus 2n, then it's going to be what? It's going to be plus 2, not plus 2. Then this is going to be just plus 1. Remember the fact that this one, right? Let me just fix that. This one is the same to the power 1, so it's going to be plus 1, right? And this whole thing is going to be divided by 2 to the power 4n, right? Then simplify this. So it's going to be 2 to the power 2n plus 2n is going to give you 4n. Then this is going to be plus 1. And this is going to be what? Divided by 2 to the power 4n, right? So now it looks like this, meaning we can apply what? We can apply law number 2, right? So let's do that. So with law number 2, we see the fact that we have a division, right? So, and our bases is the same. So this is going to be the same as, and I'm just going to continue here. So the base is 2, then you're going to have what? You're going to have 2 you're going to have 4, right? So we're going to have 4, right, to the power n plus 1, right? And this is going to be minus 4n, right? Since it's division, we are subtracting the exponential, right? So this is going to give us what? 2. Then 4n minus 4n is going to give us 0. So this is going to be the same 2. 2 to the power 1. So our final answer here is going to be 2. So that will be your final answer for this question. So now we're going to do example 2, right? It says simplify the following. So we see the fact that we have 5 to the power 2 x minus 1. Then we multiply by 9 to the power x minus 2. Then the last one in the bottom is 15 to the power 2x minus 3, right? Just a pro tip, just to say it. How do you know which one do you need to change into factors? You can basically try all of them. If you say 5, then you do the factor thing in the calculator, it's going to give you 5. So it doesn't change. So just to be on the safe side, you can do each and every number, break it down into its factors, right? Then the ones that don't change, let them be the same. The ones that changes, then change it into whatever number it gives you, right? I hope that makes sense. So here, 5 does not change. So this is going to be what? 5 to the power 2x, right? Minus 1. Then this is going to be multiply. 9 changes into what? 9 is going to change into 3 to the power 2. So this is going to be 3 to the power 2, right? Then this is going to be what? X minus 2, right? Then remember the fact that when you change it, it needs to be inside the bracket, right? Then this whole thing is going to be divided by 15 changes. And the factors is going to be 3 multiplied by what? 3 multiplied by 5, right? And this is going to be what? 2x, right? So it's going to be 2x minus 3, right? So I hope that makes sense, right? So now with that said, what we're going to do is we're going to use our laws, right? We're going to distribute the x minus 2 here, and we're going to distribute the 2x minus 3 here, right? So let's do that. So this is going to be the same as 5, then this is going to be 2x, right? Minus 1, then this is going to be multiplied by 3, then it's going to be 2, then open bracket is going to be multiplied by x minus 2, right? And this whole thing is going to be divided by what? Distribute the 2x minus 3. So it's going to be 3 to the power 2x minus 3. Then it's going to be multiplied by 5. Then it's going to be 2x minus 3, right? So now what we're going to do is we're going to simplify this one, right? So it's going to be 5, 2x minus 1 multiplied by what? Multiplied by 3. Then you're going to say 2 multiplied by x is going to be 2x. Then if you say 2 multiplied by negative 2, it's going to give you negative 4. And this whole thing is going to be what? It's going to be 3 to the power 2x minus 3 multiplied by what? By 5. It's going to be 2x minus 3, right? So now do you see the fact that in the numerator and denominator, we have a 5 and 3. So what we're going to do is we're going to apply law number 2. So for 5, same base, so it's going to be 5, then it's going to be 2x, right? So you're going to have 2x here. Let me just cancel this. So we're going to have 2x here, right? Minus 1, then this is going to be what? It's going to be minus, then here's going to be what is the same as 2x minus 3, right? And the reason why I'm putting it inside the bracket because of this negative, right? This negative needs to be distributed throughout. Then here is going to be multiplied by 3. Then it's going to be 2x minus 4, right? Minus open bracket is going to be 2x minus 3. So now let's clean that up. Let's clean the exponential part up. So it's going to be 5. Then it's going to be 2x minus 1. Then it's going to be minus 2x. Then it's going to be plus 3 because a negative and a negative gives you a positive, right? And this is going to be multiplied by, here it's going to be 3. Then it's going to be 2x minus 4. Then it's going to be minus 2x. Then it's going to be plus 3, right? So let's group like terms, right? We see the fact that we have 2x and negative 2x, that's going to give us 0. And when we say negative 1, right, and plus 3 is going to give me 2. So this is going to be the same as 5 to the power y to the power 2, right? Then this is going to be multiplied by, here we see the fact that 2x and negative 2x is going to give us 0. But when we say negative 4 plus 3 is going to give us what? Negative 1. So this is going to be the same as 3 to the power negative 1. Remember the fact that we don't like what? We do not like negative exponential. So this is going to be the same as 5 squared divided by 3, right? To the power positive 1. Since it's positive 1, I'm not going to write it, right? So further down, simplify this. This is going to be the same as having 25 divided by 3. And this will be your final answer for this question. So now let's do example what? Example of simplifying, but now it's taking out common factor, right? So this one, do you see the fact that at top we have a subtraction, right? And we have a t and a t. Do you see the fact that 2 to the power t is going to be a common factor? But for us to do that, we need to basically, this one, we're going to reverse law number 1. Do you see the fact that this is reversing law number 1, right? So what did they do? They gave us this portion. They gave us it like this. So reversing it is that we need to go from, let me just take my pen, we need to go from here to here, right? So that we can take out the common factor. I hope I'm making sense. So this is going to be the same as what? This is going to be the same as 2 to the power t, right? Then minus, remember the fact that we're reversing this one. They already added here, right? So this is going to be the same as having 2 to the power what? To the power t multiplied by 2 to the power negative 2. Do you see the fact that this looks exactly like this one? Right? So you're going to do that first. Then this is going to be divided by what? This is going to be 3 multiplied by 2 to the power t minus 2t, right? Then now, do you see the fact that I can take out a common factor of 2 to the power t? So if I say 2 to the power t, what I'm going to be left here, I'm going to be left with 1, right? So using the same rules of common factor, right? So if I take this one, if I say 2 to the power t divided by 2 to the power t, you see the fact that I'm going to get 1. So that's why we have 1 here. Then for the second one, which is going to be 2 to the power t multiplied by 2 to the power negative 1, if I divide it by the common factor, which is 2 to the power t, this I'm going to cancel out. So here I'm going to be left with 2 to the power negative 1. So that's what we're doing. So this is going to be minus negative 2, not 1. So this is going to be 2 to the power negative 2, right? So that's what's going to be left. So doing that, here again, do you see the fact that 2 to the power t is a common factor, right? So it's going to be 2 to the power t, open bracket, the first one is going to be 3, again using the rules of finding common factor, right? So this is going to be 3 and here's going to be 1, right? So that's what you're going to be left. What do we see? We see the fact that those 2 cancel out. So now what we're going to be left with? We're going to be left with 1 minus 2 to the power negative 2, right? So this is going to be the same as 1 minus 1 to the power 2 to the power positive 2, right? And this is going to be divided by 3 minus 1. So let's simplify the numerator and denominator. The first one, we can write it as 1 minus 1 over 4, right? And if we say 3 minus 1, what do we get? We get 2. So it's going to be 2, right? So now in the numerator, if we say 1 minus 1 over 4, right? What are we going to get? We're going to get 3 over 4. So we're going to have 3 over 4 divided by 2, right? So this, if you punch it into the calculator, so this, when you punch it into the calculator, it's the same as saying 3 over 4 divided by 2, right? So when you say 3 over 4 in your calculator, right, divided by 2, you're going to get what? You're going to get your answers being 3 over 8. And that's how you would solve this question. So now we're going to do a question, right, where it deals with a difference of 2 squares, right? So if you look at the numerator, we know the fact that we can change 9 into being a factor, right? So this is going to be the same as what? Here, it's going to be the same as having 3 to the power what? 3 to the power 2, right? Then this is going to be x, then this is going to be minus 1, and this whole thing is going to be divided by 3 to the power what? To the power x plus 1, right? So now what I'm going to do so that I can use the difference of 2 squared, I'm going to change the following, right? I'm going to take in the x inside and take out the exponential outside, right? So it's going to be the same as me saying 3 to the power what? To the power x, then 2. Because I know the fact that this is still going to give me the same thing. I'm still going to multiply them so I can exchange the exponential, right? If it's like this. So there's nothing wrong that I did there. This is going to be minus 1. And this is going to be 3 to the power y to the power x. Then it's going to be plus 1, right? I said the numerator, we're going to use the difference of 2 squares, right? Remember what difference of 2 squared is that we need to have 2 terms. And we see in the numerator we have 2 terms. then one needs to be positive, one needs to be negative. We have that. Then what do? We check whether each term is a perfect square, right? So that's what we're going to do. So we're going to say the square root of this one, which is going to be 3 to the power x, right? All squared, right? You see the fact that the square, this 2 and the square root are going to cancel out. So our answer here is going to be 3 to the power x. So this one is a perfect square, right? Then we already know the fact that the square root of 1 is going to give you 1, which is a perfect square. So do you see the fact that these two are both perfect square? So using difference of 2 squared, this is going to be the same as having 3 to the power x minus 1 and 3 to the power x plus 1, right? And this whole thing is going to be divided by what? By 3 to the power x plus 1. So we see the fact that 3 to the power x is in the numerator and denominator, so it's going to cancel out. So your answer here is going to be 3 to the power x minus 1. So this will be your final answer for this question. So now we're going to move to rational exponential. Remember rational, what did I say? It's fraction. So we're basically saying the fact that now our exponential is fraction, right? So we're moving to that, right? So here, what we're going to do is that we're going to do the following, right? So first thing first is that I'm going to change this 4 into being what? Into being an actual power, right? So this is going to be into being an actual factor. So we know the fact that this is going to be 2. Then this is going to be x to the power 1 over 2. Then this is going to be multiplied by what? This is going to be the same as having 2 to the power what? To the power 2, right? Then this is going to be x to the power negative 1 over 2, right? So we can take out the bracket because it was not affected by any exponential. Remember the fact that negative 1 over 2 only affects x, right? I hope that makes sense. So that's going to be the same as 2x 1 over 2, right? Multiplied by 2 to the power 2. Then this is going to be x to the power negative 1 over 2, right? So now, do we see the fact that we have the same base, which is 2, and we have the same base, which is x? So we're going to group them. So it's going to be 2. Since it's the same base, and it's the same to the power 1, so you're going to say 1 plus 2, right? So you're going to have 1 plus 2 there. Then you're going to have what? You're going to have x. Then you're going to say 1 over 2, right? Plus negative 1 over 2. Remember, we add in because of its what? Its multiplication, right? So that's what we're going to do. So this one is the same as 2 to the power 3, right? And here it's going to be the same as what? It's going to be 1 minus a half, which is going to give you 1, which is going to give you 0, right? So we know the fact that this is going to be 8, and anything to the power 0 is 1, so this is going to be multiplied by 1. So your answer here, 8 multiplied by 1 is just going to be equals to 8. So that's how you would solve this question. So now with this question, what do we need to do is that we need to first change this decimal using your calculator. So I'm going to freeze the screen and show you on the side on how to do it, right? So what you're going to do is that you're going to go to your calculator. You're going to type the 0,008, right? Then you're going to say equals to, then you're going to say shift. After going to shift, you're going to go to the C, that's SD thing that you're going to take there. Then it's going to change it into a fraction. And this is the fraction that you're going to use. So after me showing you, this is what you got, guys. You got the fact that this can be written as what? Can be written as 1 over what? 1 over 125, right? And this is going to be to the power what? To the power 1 over 3, right? So this is going to be the same as what? Distributing the exponential in the numerator and denominator. So it's going to be 1 to the power 1 over 3 divided by, right, 125 to the power 1 over 3, right? So anything to the 1 to the power any number is still going to be 1. So it's going to be 1. And here, right, we need to change this 125, right, using your factors. So if you change that, you're going to get this is going to be 5 to the power what? To the power 3. Then this is going to be 1 over 3. Then now we're going to apply law number 5. So this is going to be 1 divided by 5. It's going to be 3 multiplied by 1 divided by 3, right? So this is going to be 1 divided by, if you say 3 multiplied by 1 over 3, you're going to get 5. So 1 over 5 is going to be your final answer for this question. So now we're going to move to exponential equations. That said, we're going to deal with solving exponential laws through equations, right? So now let's do this first question. So here we are solving for x, right? The questions that I'm going to be doing is we are solving for x, right? So here, what do we see? We see the fact that we have 3 to the power x plus 1 is equals to 9. So now what we need to do is that we need to match up the bases. That's your goal. We always match up the bases, right? We need to make sure the fact that the bases are the same. So here we know the fact that 9 is what? It's 3 to the power 2, so it's the same as 3. Then it's going to be x plus 1 is equals to 3 to the power 2. So now since we have the same base, right, we can do what? We can actually drop the exponential, the base, right, and equate the exponential. So this is going to be the same as x plus 1 is equals to 2. The reason why we could do that, remember the fact that this is 3 and 3 is the same base, so we can drop them and equate the exponential. I hope that makes sense, right? So now we can just solve for x. So take the 1 to the other side. So it's going to be x is equals to 2 minus 1. Therefore, x is going to be equals to 1. So that's how you would solve for x in this question. So now we're going to do example 2. Again, we are solving for x, right? But now this one looks a little bit tricky, right? It's like, oh my God, what can I do? But remember the fact that I told you the fact that there's a law that says the fact that anything to the power 0 is equals to 1. So that's the law that we're going to use. Remember here, we need to do what? We need to match up the bases so we can drop them and equate the exponential. So this is going to be the same as saying 3 to the power x is equals to 3 to the power 0. Because we know the fact that anything to the power 0 is 1, which goes back to this. So you did not change anything about the equation, right? So now with that said, we know the fact that the bases are the same, so we can drop the bases. So it's going to be the same as x is equals to 0 when we equate the exponential. So here x is actually equals to 0. So now let's do example 4, right? And I want to just go back to example 3 to show you a difference between example 4 and example 3, right? So if you look at example 3, do you see the fact that here we added, right? Do you see the fact that here it's 1 with the x and the other one it's added together, right? Example 4 is that, do you see the fact that one of them is 2x and the other one is x? And the bases are the same. Do you see that? The bases are the same, right? Is that if you see one with a power of 2 to the power x and the other one with the power of just x and the bases are the same, always know the fact that you use your k method. We're going to let, what you call this, 3 to the power x, right, to be k. So here, always when you see it like this, where one is to the power 2x and the other one is to the power x, we always let, right? It makes it simple. You're going to say let k is equals to 3 to the power x, right? So this one, and I'm just going to rewrite it, right? This is the same as, so I'm just going to first write it in terms of x. This one is the same as saying 3 to the power x, right, multiplied by 3 to the power x. Because when you add up the exponential, it's going to give you 2x, right? And this is going to be minus 80 multiplied by 3 to the power x minus 81, right? It's equals to 0. So this is the same as k multiplied by k minus 80. Then this is going to be k. Then this is going to be minus 81 is equals to 0. So that's the same as k squared, right? K squared minus 80 k, right? Minus what? Minus 81 is equals to 0. Do you see the fact that now it's like a quadratic? So I can basically factorize this, right? So I'm going to use it's going to be here, it's going to be k plus 1, then it's going to be k minus 81 is equals to 0. So this is the same as what? As having k is equals to negative 1, or it's going to be the same as having k is equals to 81, right? So here substitute your k into being 3, remember? So it's going to be 3x is equals to negative 81. Or it's going to be 3 to the power x is equals to 81, right? Negative 1. So here, 3 to the power x can never be a negative number. So this, you can't look at it, right? So your answer is going to be here. So it's going to be 3 to the power x is equals to 81, right? Change 81 into being a factor. So it's going to be 81, right? Change it into a factor. So it's going to be the same as 3 to the power 4. Let me just change this one, because I can't rewrite the same thing. So it's going to be 3 to the power 4, right? So the bases are the same. So x is basically equals to 4. And that will be your final answer for this question. So now let's do example 5, right? It says x minus 13x to the power 1 over 2 plus 36 is equals to 0. So if you see a question like this, or it can be also written in this form, right? If you see this type of questions, you approach it the same way, right? If you have x, now they say 13, then they say the square root of x plus 36. This is the same thing, because when we change this 1 over 2, it's actually root x, right? And this is equals to 0. So this and this is the same thing, right? So if you have the same thing, meaning it's either you can write it like this or like this, then you need to approach it in the same manner, right? So how do we do it is that we let, right, k be equals to root x, right? Or in our case, 1 over 2. So, or let me just say x to the power 1 over 2. It really means the same thing, right? So after doing that, we're going to substitute. So what do we know? We know the following, right? We know the fact that if I say right now, right, from the exponential laws, right, if I say x to the power 1 over 2 multiplied by x to the power 1 over 2, I can add exponential, right, which is the same as what? As 1 over 2 plus 1 over 2. What's 1 over 2 plus 1 over 2? It gives me x. So do you see the fact that this x is basically going to be what? 2 1 over 2. So let's write it like that. So I'm just going to write this. It's going to be x to the power 1 over 2, because I know the fact that that's x, multiplied by another x, which is going to be 1 over 2, minus 13. Then it's going to be x to the power 1 over 2 plus 36, right, is equals to 0, right? So with that said, I know the fact that this 2 is 1. So this is the same as having k multiplied by k minus 13. K plus 36 is equals to 0. So this is the same as k squared minus 13, right? K plus 36, right, is equals to 0. Do you see the fact that now again we need to factorize? So let's go do that, right? It's going to be what? It's going to be k minus 4. Then it's going to be k minus 9 is equals to 0, right? So which is, we know the fact that it's already equals to k is equals to 4. Or from here, right, a is equals to 9, k is equals to 9, right? So you substitute what k was. We know the fact that k was equals to what? 2 root, I'm just going to change it to root x is equals to 4, because it's easy to solve it that way. Or it's going to be root x is equals to what? Is equals to 9, right? So now with that said, right, we're going to do the following, is that we're going to square root both sides, right? We're going to square both sides to get rid of the square root. So it's going to be what? It's going to be the same as this, all squared is equals to 4 squared. Or it's going to be again this, right? All squared is equals to 9 squared, right? So here x is going to be equals to what? X is going to be equals to 4 squared, which is going to give me 16, right? Or here it's going to be what? It's going to be 9 all squared, which is going to give me x is going to be equals to what? It's going to be equals to 81. So x is going to be 16, or x is going to be equals to 81. And that's how you would solve this question. So now let's do example 6, right? It says 2x, 2 to the power x minus 2 to the power 4 minus x is equals to 0, right? I said if you have it like this, you're basically going to use this law, but you're going to reverse it, right? So let's do that first. So it's going to be 2 to the power x minus 2 to the power 4 multiplied by 2 to the power negative x is equals to 0. We never want to deal with negative exponential, so I'm going to take it to the denominator. So it's going to be 2 to the power x minus 2 to the power 4 divided by what? Divided by 2 to the power x is equals to 0. The minute you have this form, right, where 1, which is going to be the same thing, like anything to 2 to the power whatever you're looking for, like the unknown, like 2 to the power x or 3 to the power x, and you have the same thing in the denominator, right? You're always going to do the following. You're going to let k again, right? So you're going to say let k, because you're going to see what's going to happen. You're going to say let k equals to 2 to the power x. So substitute. So it's going to be k minus what? minus 2 to the power 4 divided by what? Divided by k is equals to 0, right? So take what? Take, what you call this? I want to get rid of the denominator. So I'm going to multiply here and here by k. So it's going to be k multiplied by k. I can multiply where the denominator is. I can multiply 2 to the power 4 by k because it's already divided by it. So it's going to be minus this. I'm going to change it. So 2 to the power 4, right? It's going to give me what? It's going to give me 16. So it's going to be 16. Then 0 multiplied by k was just going to give us 0, right? So this is going to be k squared minus 16 is equals to 0. Take it to the other side, the 16. So it's going to be k squared is equals to what? It's going to be equals to 16 positive, right? Square root both sides. So it's going to be the square root of k, right? So it's going to be the square root. I don't need to write the 2. Why did I write it? Right? Square root both sides. And this is going to be what? This is going to be plus or minus square root of 16, right? Which is going to be the same as k is equals to what? Square root of 16 is 4, which is going to be plus or minus 4, right? So this is going to be plus or minus 4, right? So now this means the fact that k, and I'm just going to write it here. This means that k can be either equals to negative 4 or k can be equals to positive 4. And the reason why again is plus or minus is because of our 2 is an even number. Our power isn't in the even number, right? So now we're going to go back and substitute 2 to the power x. So it's going to be 2 to the power x is equals to negative 4. Or it's going to be 2 to the power x is equals to 4. It can never be a negative, so this one does not, it's not applicable. So we're going to solve here. So it's going to be 2 to the power x. Change this one is going to be the same as 2 to the power 2. So therefore, x, dropping the base, is going to be, x is going to be equals to positive 2. And that will be your final answer for this question. So now we're going to do solving equations by factorizing a trinomial, right? Still solving exponential, right? So remember, first, if we have something like this, we need to what? We need to reverse it, right? So we're going to reverse it using rule number 1. So that's the first thing that we're going to do. So you're going to say this is going to be what? This is going to be 2 multiplied by 5. Then this is going to be the same to the power 2 multiplied by what? By 5 to the power negative x. And this is going to be equals to 5 plus 5x, right? So that's what you're going to have, right? So after doing that, we know the fact that we hate what? We hate negative what? We hate negative exponential. So I'm going to change that. Do you see the fact that 2 multiplied by 5 multiplied by 2 multiplied by 5 to the power 2 multiplied by 5 to the power negative x, they're all multiplying each other, right? So me taking this into the denominator, meaning my numerator is going to be 2 multiplied by 5 to the power 2 divided by what? By 5x, right? And this is going to be what? 5 plus 5x, right? So now, what do we see? How do we know that we are actually going to use a trinomial? This is what's going to give you an indication. Do you see the fact that here you have 5 to the power x in the numerator, the x that you want in the numerator, and also on the other side, you have it in the, like you have it here in the denominator, that's what I mean, and on the other side, you have it in the numerator. That's when you know the fact that, okay, cool, I need to use substitution, let k, right, to basically change this into being like a quadratic, right? So that's what you're going to do. So if you have a question, right, where you have a negative exponential, you took it down, and on one side, right, like on one side, we have it in the denominator, and on the other side is in the numerator, then in your head, what should click? It's let k, right? I hope that made sense, right? So that's what we're going to do. So we're going to say the following. So where's my pen? We're going to say let k. So here we're going to say let k, right, equals to what? Equals to 5, the one that I just highlighted. The one is in the denominator that has the x that we're solving for, right? The one that's in the numerator, and the one is in the denominator, which is 5 to the power x. So it's going to be 5 to the power x, right? So that's what you're going to do. So now you're going to, everywhere you see 5 to the power x, you're going to substitute it by that. So it's going to be the same as 2 multiplied by 5 to the power 2 divided by k is equals to what? It's equals to 5 plus k, right? So now let's basically simplify this. If I say 2, right? If I say 2 multiplied by what? By 5 to the power 2, I'm going to get what? I'm going to get 50. So this is going to be 50, right? And it's going to be divided by what? K, right? And this is going to be equals to what? 2, 5 plus k, right? So what I need to do is that I have a fraction this side, right? And I want to get rid of it. Yes, I want to get rid of it, right? Since we have what? Since we have an equal sign, right? I can use what? Cross multiplying, right? So this whole thing is the same as divided to 1, and I'm going to cross multiply like this. So cross multiply, I'm going to say 50 multiplied by 1. Then this is going to be equals to k. Open bracket, I'm going to have 5 plus k, right? Then this is going to give me just 50, and this is going to give me what? Distribute the k, so it's going to be 5k plus k squared. Do you see the fact that we're forming a what? A quadratic, right? So now, with the quadratic, remember the fact that for us to factorize a quadratic, it needs to be in this form. Let me just write it here. We know the fact that it needs to be in this form. It needs to be the form of ax squared plus bx plus c is equals to 0. Where in our case is the same as ak squared, right, plus bk, right, plus c is equals to 0. So let's write it in that form. So if I write it in the form is that the other side needs to be equals to 0, right? And the one with the k squared comes first, the one with k only comes second, then the one with the number comes last. So let me take my 50 to the other side. So this is going to be equals to, so that's going to be the same as 0. Take the 50 to the other side is equals to 5, right? Then it's going to be k plus k squared, right? Then this is going to be minus 50. Write it in this form, and I'm just going to take it up here, right? If I'm going to write it in that form, it's going to be 0 is equals to what? 2k squared, representing the first one. Then it's going to be plus 5k, right? Then this is going to be minus 50. So it's in this form, which is perfect, meaning I can what? I can factorize. So I'm going to factorize this. So it's going to be equals to, when I factorize this is going to happen is that you're going to have k, right, minus 5. Then here's you're going to have k plus 10, right? So that's sorted, right? So what we're going to do is we're going to equate each bracket by 0. So this is going to be the same as k minus 5 is equals to 0. Or, right, you're going to say k plus 10 is equals to 0 because we're solving for k first, right? So when we do that, we're going to take the 5 to the other side. So this is going to be the same as k, right, is equals to what? Is equals to positive 5, right? This side is going to be the same as k is equals to what? It's equals to negative 10, right? So now, since we have it like this, I can go back and substitute this. K as, I can go back and substitute 5 over x because that's k. So you're going to say 5 over x, right? 5x is equals to what? Is equals to 5. Then this side is going to be 5x is equals to negative 10. If you have a number where it's equals to a negative number, this is not applicable. So this is undefined. This can never happen, right? Our equals to, our exponential, right, term needs to always be equals to a positive number. It can never be equals to a what? To a negative number. I hope that makes sense. So this answer does not exist. So you're going to put this there. Then now we're just going to deal with this one. What do we see? We see the fact that this is to the power what? To the power 1. So this is going to be the same as x to the power x is equals to x to the power 1. Do you see the fact that we have the same base? So we can drop the bases and equate the exponential. So x here is going to be equals to 1. And this will be what? This will be your final answer for this question. So now what we're going to do surds, right? So we're going to start with the first thing, which is rational exponents and surds. Remember that rational means what? It means fraction. So this is the same as fraction exponents and surds, right? So the first thing that we need to understand is rules, right? It's the rules, and these are the different rules. So rule number 1 says if r to the power n is equals to a, if I just want r without any power, what do? I am gonna introduce a root that has the same exponents in both sides, and this and the other one's gonna cancel out, which is you're gonna end up with this one. So let me just show you in like retrospect on how to make r without an exponential. If you want to get rid of the exponent, what do you do, right? So we see the fact that we have r to the power n, right, is equals to what? Is equals to a, right? So that's what we have. So now we want to get rid of this exponential. So how do we get rid of it? We're gonna enroot both sides. And the reason why we enroot because of is to the power n, right? So the root that we are introducing needs to be what? It needs to be whatever the exponential it is, right? So this is going to be r to the power y to the power n is equals to, introduce it on both sides, so it's going to be n root, then it's going to be a, right? So this root and this power are going to cancel out, so it's going to be r is equals to n root a. So now let's just do it in terms of if they give you like a value, right? So if this is like maybe x to the power 2 is equals to maybe 3, right? So how do we get rid of this power? Remember the fact that we introduced the root that has the same thing. So this is going to be the same as root, right? Because this is the same as 2 is. So root 2 and this one is the same thing, right? So it's the same thing. So this is going to be x to the power 2 is equals to 3. The root and the 2 is going to cancel out. So this is going to be the x like root here. So this is going to be x is equals to root 3. I hope that makes sense, right? So that's how you would do it, right? So that's how the first law is basically interpreted, right? And this is how you would do it, right? It's basically getting rid of what? It's basically getting rid of the what you call this power if you just want that term alone. I hope that makes sense. So number 2, it says what? It says a to the power 1 over n is the same as the n goes in front, then there's going to be the root, right? So do you see the fact that what's going to happen is that if you have 1 over, if you have a fraction, right? If you have an exponential of the fraction, the denominator is going to be the 1 of the root. I hope that makes sense, right? So let me just do an example here. If you're given maybe like, for instance, you're given like 3 root, let's just do it from the power point of view. I'm going to do it in a power point of view. So let's do this. So if you're given like 2 to the power 1 over 4, right? We can rewrite it as a surd, which is going to be what? It's going to be 4, right? That is going to be the root of 2. So your base goes inside the root, then that number that is in the denominator comes here. So that's how you would do it, right? So I hope that made sense. So now let's move to number 3. It says if you have a negative, right? If you have a negative, fraction of negative fraction of an exponential, the first thing that you need to do is you're going to take out the negative unknown, right? Put in a bracket, then we're going to have this. Change this from being a negative exponent to a positive, then you're going to apply your root. So again, right? Let's just put in example this to this, right? So if you're given 2, right, to the power 1 over 3, right? So this is going to be the same as what? First, we need to basically take this out and basically write it to the power 1. Because we know the fact that if we say negative 1 multiplied by 1 over 4, we're still going to end up here, right? So this is going to be the same as what? As 2 to the power what? To the power negative 1. Then you're going to say this, and this is going to be 1 over 3, right? So this, change this into a positive first. So it's going to be 1 over 2, right? To the power 1 over 3. And this is going to be the same as 3 root. Then it's going to be 1 over 2. I hope that made sense, right? Then the last one says what? It says if you have a to the power m divided by n, this is the same as what? This m, the one in the numerator, is the same as multiplying to the actual base, right, alone, than multiplied by 1 over n. Because we know the fact that if we use the law of exponential here, if we say m multiplied by 1 over n, we're going to still come back here, right? And that is going to be equals to this. Again, let's just do an example. So if you're given maybe 2 to the power, let's say 3 divided by 2, right? So this is basically the same as having what? You're going to say 2, then you're going to take your numerator, then you're going to say 3, then you're going to close inside the bracket, there's going to be 1 over 2, right? Then after doing this, you're going to change this into a surd. So this is going to be the same as the root of what? 2 over 3. I hope that makes sense. So that's how you would basically look at this rule, right? So with that said, I'm going to do a couple of examples. And I know the fact that I've touched base on the other ones when I was just showing you individual rules, right? So the first one, let's do that. We see the fact that we have 18 1 over 2. Now let's change this into a surd, right? So how do we change it into a surd? For number one, it's going to be what? It's going to be, remember the fact that 2 root, right, is the same as root, right? So since this is to the power a half, so this is going to be the same as the root of 18, right? So that's sorted. So now we're going to do number 2, right? We're going to need to simplify this. When we simplify it, what do we see? We see the fact that we have negative 125, right? So we know the fact that we can do what? We can change. So we have negative 125, right? So first, negative 125 to the power y to the power negative 1 over 3. So this is like the second rule, right? So this is going to be the same as, say, negative 125, right? And this whole thing is to the power negative 1, right? And this is going to be to the power negative 1 over 3, right? So I'm writing a square bracket because you see the fact that I took out the negative 1 here, right? So that is why I'm putting the square bracket. So this is going to be the same as what? This is going to be the same as saying what? The cube root of what? Of negative 125, right? To the power negative 1. Remember the fact that this is a negative and exponential. So that's going to be the same as like this. So it's going to be 1 divided by negative 125, right? Changing this negative exponential to a positive. So this will be your final answer. I hope that makes sense, right? So now moving to what? Moving to question 3, right? So question 3, we have the following. We have, let me just write it here. We have the fact that 4, then this is going to be 3 to the power 2, right? So first, remember, what did I say? I said you take the base, right? And you're going to take the numerator, which is going to be 3. Then you're going to close in the bracket. Then this is going to be 2, right? 1 over 2. Remember, the denominator is going to be 1 over 2. So now let's apply that. So remember the fact that this and this is the same thing. So it's going to be root of what? Of 4 to the power 3. So that's how you would do this one, right? Number 3. So now let's do number 4. Number 4, you have the following. So you're going to have negative 81, right? To the power 1 over 2, right? So what you're going to have here, you're going to have the following. You're going to have, since it's what you call this is going to be a half, so this is going to be the same as the root of negative 81. Remember, so here, if you have a root of negative, what you call is negative 81, this is going to be what? This is going to be not real. So if you punch this in the calculator, you're going to find math error. So this is not real, right? So to emphasize this more, is that if you have a negative number, right? So if you have a negative number inside any positive root, right? So positive, like any even, not positive, any even root, right? It's always going to be what? Not real. So other examples, which is I'm going to do it with another color. Other examples could be the fact that if you have 4, then this is negative 3. This is going to be not real. Even number, any even number, right? Also, if you have 6 root negative 3, it's going to give you what? Not real. So if you put in what? If you have, if your root is an even number, so these numbers are even, right? And inside you have a negative number, it's always going to be unreal. But if it's an odd number, then it's fine. So this one exists. Do you see the fact that this one exists, even though it's negative? Only if our root is an even number, it's going to be always unreal. So any even number, so 10, 15, 20, any even number is going to give you undefined. I hope that makes sense, right? So I just wanted to emphasize this more. So that's that. So now let me just change back to my color. So now we're going to do number 5, right? So number 5, again, we're going to have what? We have 0,008, right? 1 over 3. So what you're going to do is that you're going to change this, right? So how do we change this? You use your calculator. So when you use your calculator, you're going to see the fact that 0,08 is the same as what? It's the same as 1 over 20. It's 1 over 125, right? To the power 1 over 3, right? So remember the fact that I need to write this in surd form. So it's going to be the same as cube root of 125. And that's how you would rewrite every rational number, right, in a form of what? In a form of a surd, right? I hope that makes sense. So now we're going to do example 2 under rules, right? We're basically going to change this without using a calculator. We're going to change it into what? Into being a surd form, right? We're going to simplify it. Then after simplify it, we need to make sure the fact that our answer is either in a surd form or it's either in terms of numbers. I hope that makes sense, right? So the first thing that we need to do is that we need to sort out the parts that are inside the bracket, right? So we see the fact that we have 4 to the power -1 and we have 9 to the power -1. So let's sort that out. So we do not want to deal with what? We never want to deal with any what? Any negative exponential. So that's going to be the same as 5 divided by 1 divided by 4, right? Minus, then it's going to be 1 divided by 9, right? And this is going to be to the power 1 over 2, right? So that is sorted. We have gotten rid of what? Of our negative exponential. But right now is that you see the fact that our denominator doesn't look good. So we need to find a common factor, right? After finding common factor, then we can make everything to be like just one fraction, not 2 fractions adding each other, right? So what do we see here? We see the fact that I can multiply what? I can multiply this with this 1, right? Then I can multiply this 9 with this one using fraction rules, right? Just remember that we're using fraction rules. Then finally, I can multiply the bases together, right? So that's what we're going to do. So let's do that. So it's going to be what? It's going to be 1 multiplied by 9 minus 1 multiplied by 4. So it was green multiplied by another green. Then it was what? It was yellow multiplied by yellow. This is 4. Why am I saying 5? Let me just erase that. So this is 4, right? And this is divided by what? I am doing a mistake. I forgot the 5 on top. I just went to just solving the denominator. So let's just do this. So this is going to be equals to, right, to 5. Then we're going to deal with the denominator. I said is the green multiplied by the green. So there's going to be 1 multiplied by 9 minus 1 multiplied by 4, which is yellow, right? And this is divided by the blues multiplying, which is going to be 4 multiplied by what? By 9, right? And this whole thing is going to be to the power 1 over 2, right? So now you're going to have 5. Then this is going to be divided by what? By 9 minus 4 divided by what? Divided by 36, right? And this whole thing is going to be to the power 1 over 2, right? So now with that said, I'm just going to continue it here. It's going to be the same as what? When you say 9 minus 4 is going to be the same as 5. So it's going to be 5 divided by 5 divided by 36, right? This whole thing is going to be what? It's going to be to the power 1 over 2. So I can rewrite this. So 5 divided by 5 divided by 36 is the same if I said 5 divided using the division side by 5 divided by 36. So that's the same thing. So this is going to be what? This is going to be 5, right? Then this is going to be divided by what? By 5 divided by 36, right? And this whole thing is going to be to the power 1 over 2. Remember they say without the use of a calculator, so we can't use a calculator, right? So this is going to be what? Now we're going to change the division to multiplication. So let's do that. So it's going to be 5, right? Multiply. Remember the fact that the numerator goes to denominator and denominator goes to numerator, the term after the division. So this is going to be 36, right? Divided by 5. And this whole thing is to the power 1 over 2, right? So now what we're going to do is we're going to multiply numerator to numerator and denominator to denominator. So it's going to be 5 multiplied by 36 divided by 5, right? So this whole thing to the power 1 over 2. So the 5s are going to cancel out. So you're going to be left with just 36, right, to the power 1 over 2. Now we can basically change this into a square root, right? So it's going to be the same as root 36. 36 is a perfect square, so therefore our answer is going to be equals to 6. So this will be your final answer for this question. So now we're going to move to set laws, right? So we're going to be answering set laws. So this is the following laws, right? So now let's just discuss it and look closely to it, right? Is that what do we see? We see the following. We see the fact that here, what are we expected to be the same? We expected that the
root number is the same. If the root number is the same, then if I'm multiplying the same, the same two numbers with the same root, I can basically take them into the same root. Do you see that? I can multiply the two numbers because of the roots are the same, right? Same applies with division. Then here it says the fact that if I have a root inside another root, I can basically multiply those two roots to create one big root like this, right? And here it says what? It says a to the power what? A to the power m, right? The root of n, right? Inside a to the power m is basically m divided by n. So this is taken from this. Let me just show you this one. Number 4 is that we have n, right, to the root of a to the power m, right? So this can be written as what? As being an exponential. So this is the same as saying a to the power m to the power what? 1 divided by n, right? Which now, remember the laws of multiplying, which is the same as a to the power m multiplied by 1 divided by n, which is the same as m divided by n. That's how we got here, right? And number 5, let me just do it. Also do that. This is the same as the following. If we have n root a, right, then it's inside the power m, right? It says it's equals to this. So this is the same as rewriting this as an exponential. So this is going to be the same as a to the power 1 to the power n, right? And this is going to be multiplied by m, which is going to be the same as 1 divided by n multiplied by m using the exponential laws. So this is going to be the same again as m divided by n. So that's how you would get here. So that's how you would look at Surds, rules of Surds, right? So now we'll be applying law 1 of the exponential. So I put in the exponential laws, not the exponential, the Surd laws on the side here, right? So I've put them there. So law 1 is just this one, right? So what does it say? It says the fact that if you have the number on the root here, if it's the same, right? Then what can you do? You can multiply the terms that are inside the root, right? So that's what we're going to do. So number 1, since this and this are the same, we can basically put it in one big root and say 3 multiplied by 6. And you're going to get what? You're going to get the fact that 3 multiplied by 6 is the same as the root of 18. So that's how you would do it, right? And number 2, do you see the fact that is the square root and square root? So it's common. So this is going to be what? The square root. Then you're going to say x multiplied by 4, which is going to give you what? The square root of 4x, right? So that's how you would solve the two equations. Now, law number 2 says the fact that if the numerator and denominator have the same root, what can you do? You can basically divide the number on top with the number at the bottom. So do you see the fact that that's law number 2, right? We see the fact that we have root, square root, and square root. So we can basically write a big square root. So we know the fact that root 3 divided by root 6, right, is going to be equals to a big root. Then we're going to say 3 divided by 6, right? We can simplify this fraction. So if we simplify this fraction, it's going to be basically 1 over 2. So this is going to be what? It's going to be the square root of 1 over 2. And that's how you would apply law number 2. So now we're going to be applying law number 3, which says the following. If you have like a root, then inside a root, there's another root. What can you do? You can basically write one big root, right, and multiply the terms of the roots, right, and whatever number that's inside, you're going to write it, right? I hope that makes sense. So here we have the fact that we have a square root, then inside a square root, there's another root, right? And that's root, this is another square root, but with 81. So it says the following. It says the fact that if I have a root and a root, right, of 81, this can be written as what? Since this, remember the fact that I said 2 root, right, is the same as just root. Since we know the fact that this represents 2, this is the same as saying 2 multiplied by 2, right, inside root of 81. So this is the same as the 4th root of 81. I hope that made sense, right? So this is number 1. Then number 2, right, we see the fact that this is 3 and this one is just going to be 2. So this is going to be the same as, say, 3 multiplied by 2, root of what? Root of 2x. Simplify that
it's going to give us the following. It's going to be 6 root, right, of 2x. So that's how you would apply law number 3. So now applying law number 4 and law number 5. So number 1 is law number, actually, this is going to be law number 4. Then this one is going to be law number 5, right? So I'm just going to be doing them at the same time. So this is going to be law number 3 and law number 4 and law number 5. So now let's start with law number 4, right? What do we see? We see the fact that if we have it like this, we can basically write it in an exponential, right? So let's do that first, right? So this is going to be the same as what? Remember the fact that if you have 3 root, then this is x to the power 4. This is the same as what? This is the same as having x to the power 4, right? And this is, remember, root 3 is the same as 1 over 3, right? So this is going to be the same as having x. Now applying exponential, this is going to be 4 multiplied by 1 over 3, which our answer is going to be x to the power 4 divided by 3. So that's will be your final answer for this one, which is exactly in this form, right? So now number 2, which is applying law number what, right? Now we're applying law number 5, right? It is the following. So we know the fact that it's the square root of 2 to the power 3, right? So first, what you need to do is that we need to change the one that's inside a bracket, right, into being an exponential. So we know the fact that this is the same as 2 to the power 1 over 2, right? Because the square root means 1 over 2, then this is going to be to the power 3. Then we're going to apply exponential law. So it's going to be 2, then it's going to be 1 over 2 multiplied by 3, which is going to be the same as 2, which is going to be what? It's going to be 3 divided by 2, which is we just written in this form. And that's how you will apply law number 4 and law number 5. Let's do example 1, right? It says 5 multiplied by root of 3. Inside then it's going to be x to the power of 4, then it's equals to 405, right? So first we're going to need to get rid, we need x alone. So I'm going to divide 405 divided by 5. So it's going to be what? It's going to be 3 root x to the power of 4 is equals to what? I'm going to say 405, right, divided by 5, which is going to give me 81. So this is going to be equals to 81, right? So now I'm not going to do the law. I'm not going to apply which law is this one. It's going to be this one. I'm not going to apply this law, right? It's going to make everything complicated. I'm going to what? I'm going to put everything to the power 3 to get rid of this root 3, right? So I'm going to do that. So I'm going to say root 3, that's going to be x to the power 4. Then this is going to be what? It's going to be to the power 3 because I want to get rid of it. Then here's going to be 81 to the power 3, right? So that's what we're going to do. So here I'm going to be left with x to the power 4 is equals to what? To 81 to the power 3, right? Which is going to give me the following. So it's going to be 5, 3, 1, 4, 4, 1, right? Then now I want to get rid of the 4. So what I'm going to do is I'm going to root, what you call this, fourth root everything, right? So I'm going to do this, right? And this is going to be equals to what? This is going to be equals to fourth root this also. So it's going to be 5, 3, 1, 4, 4, right? Is it 4, 4, 1, right? So when I do that, it's going to be, so it's going to be that to the power 4, right? So it's going to be 5, 3, 1, 4, 4, 1, right? So it's going to be 27. So x is going to be, since it's an even number, it's going to be equals to plus or minus 27, right? So meaning x can be equals to negative 27 or x is equals to positive 27. Since we are dealing with roots, right, square root, what we need to do is that we need to check which one is the right one, right? So how do we do that? We have to substitute x negative 7 into the equation here. And if here I substitute here the left hand side and I get it to be what? To be 405, then I'm going to pick it. If I'm not going to get it to be if I substitute here, right, and I get to be 405, right, meaning the left hand side and the left hand side and the right hand side are equal to each other, then I'm going to pick that answer. If they're not equal to each other, the left hand side and right hand side, then it's not the answer. So let's do the first one. So when we substitute x to be 27, so it's going to be the same as 5, then it's going to be root 3, then here is going to be what? It's going to be negative 27, then this is going to be to the power of 4, so this is going to be equals to what? It's going to be 5, then it's going to be multiplied by root 3, then open bracket, it's going to be negative 27, right, to the power of what? To the power of 4. I'm going to get the fact that this is going to be equals to 405, right? So this is part of our answer. And so meaning this one is going to be part of our answer. Then now if we test, substitute when x is equals to 27, right? So it's going to be 5, then it's going to be root. Then here it's going to be 27 to the power of 4. We're going to get the fact that when you pass that, you're going to get the fact that it's 405. So we see the fact that both x to the power, x equals to negative 27 and x2 positive 27 are both our answers. So therefore, we can conclude that both of them are our answers. So therefore, x is basically equals to plus or minus 27. I hope that made sense. So now let's do example 2, right? We're still solving for x. So here, remember the fact that we need x alone, but x is within, it has negative 2 inside a square bracket. So the first thing that we're going to do, we're going to take the 3 to the other side. So it's going to be the square root of x minus 2 is equals to positive 3, right? Then what we're going to do is we want to get rid of the square root, meaning I'm going to square both sides by what? By x by 2, right? So I'm going to square both sides. So it's going to be like this. So I'm going to be left with x minus 2 because the square root and the square is going to cancel out. And this is going to be 3 squared, which is going to give me 9, right? So now what I'm going to do is I'm going to take the 2 to the other side. So x is going to be equals to what? X is going to be equals to 9 minus 2, right? 9 plus 2, sorry, it's going to be 9 plus 2, which is going to give us 11. So x is going to be equals to 11, right? But remember the fact that we're dealing with roots, so we need to test our answer. So I'm going to substitute x equals to 11 here, right? And if I get 0, then this is part of our solution. If not, then it's not part of our solution. So it's going to be root, then it's going to be 11 minus 2 minus 3. Then let's test it out. It's going to be 11 minus 2. Then you're going to say minus 3, right? You're going to get 0. So this is going to be 0. So we see the fact that the left hand side are equals to each other. So therefore, x, the left hand side is this one. Let me just say, this is the left hand side and this is the right hand side. So therefore, we know the fact that x is basically equals to 11. So that's how you would do this question. So now we're going to do example 3 under what? Under equations, right, of like involving surds, right? Solving equation that are involving surds. So example 3 says what? It says x plus 2 is equals to what? Root 7 plus 2x, right? So what do we do here is that, do you see the fact that on the other side is what? Is an expression that's inside the square root, right? So there's nothing that we can do. We can't take 2 to the other side. We can't do that. Since it's like this, what you need to do is that we need to get rid of this square root. So let's do that. How do we get rid of the square root? Is that we need to raise it to a power of 2 because this is a square root. So we're going to square root both sides. So this is going to be what? This is going to be x plus 2 all squared is equals to root, right? This is going to be 7 plus 2x. Then it's going to be all squared, right? So with that one, then now we need to expand this side. So we expand this side, it's going to be x squared, right? Plus what? Plus 4x, right? And this is going to be plus 4. And this is going to be equals to what? This side is going to give us the square root and the power, they're going to cancel out. So you're going to have 7 plus 2x, right? Do you see the fact that now we have like a quadratic formula, right? So we're going to take everything to one side. So I'm going to take everything to this side because of I have x to the power 2 as being positive here, right? So I'm going to have x squared plus 4x, right? Plus 4, then you're going to say minus 7, then you're going to say minus 2x is equals to 0, right? Group like terms. So when you group like terms, x squared is alone, so it's going to be x squared. We see the fact that 4x and negative 2x are together. Let me just highlight like terms, right? So we see the fact that this and this are together, right? So that's sorted. And we also see the fact that the constant here are together, right? So that's what we're going to do. We're going to say 4x, right? Then we're going to say, we're going to say 4x. Then we're going to say minus what? Minus 2x. So if we say 4x, so if we say 4 minus 2, I'm going to get a positive 2. So this is going to be plus 2x, right? Then you're going to say 4 minus 7, you're going to get what? You're going to get negative 3, and this is going to be equals to 0, right? So after getting this, what we're going to do is we're going to basically factorize this. So when you factorize this, it's going to be x minus 1, right? And this side is going to be x plus 3. And this is going to be equals to 0, right? So after having that, we basically solve for x. So it's going to be x minus 1 is equals to 0, or it's going to be x plus 3 is going to be equals to 0, right? So my x here is going to be x is equals to, take the 1 to the other side, positive 1. Then this side is going to be x is equals to negative 3. But we are not done because we're dealing with square root. We always need to check our answer. So here, checking our solution or our answer. So checking, right? Checking the solution. Remember the fact that we want the left-hand side to be equals to the right-hand side. This is the left-hand side, right? We need it to be equals to the right-hand side. If when we substitute our solution, our left-hand side and right-hand side are equals to each other, then that is the solution. If not, then that's not, right? So now we're going to first substitute. We're going to substitute what? We're going to substitute our first solution, which is x is equals to 1, right? So I'm going to substitute it to the left-hand side. So I'm going to say left-hand side is going to be equals to what? To x plus 2. So this is going to be the same as 1 plus 2. And this is going to give me 3. So we know the fact that the left-hand side is 3, right? So now going to the right-hand side, right? We're going to say the following. We're going to say, we know the fact that the right-hand side is the square root of what? The square root of 7, right? Plus 2x, right? So this is going to be the same as what? It's going to be the square root of 7 plus what? Plus 2. Then this is going to be 1 here, right? So 7, so this is going to be the 7 as 7 plus 2. What? 7 plus 2 is going to be 9. What is the square root of 9? Is basically 3. So we see the fact that the left-hand side and we see the fact that when we substitute 1, right, the left-hand side and the right-hand side are equal. We see the fact that left-hand side is equals to right-hand side, right? That means x equals to 1 is part of our solution. So that's sorted, right? So that means the fact that therefore x is equals to 1, right? So that's part of the solution, right? So now we're going to have to check when we substitute. And I don't know. Okay, let's just do it here, right? So now let's check when we substitute what? When we substitute x is equals to negative 3, right? So we're going to start with the left-hand side. So it's going to be what? X plus 2. So substitute, wherever we see x, we're going to substitute by negative 3. So it's going to be negative 3 plus 2. So here what we're going to get? We're going to get negative 3 plus 2. We're going to get our answers being negative 1. So this one is going to be negative 1, right? So that's what we're going to have, right? So now we're going to check the right-hand side. So right-hand side, right, is going to be what? Square root of 7 plus 2x, right? So we're going to substitute negative 3. So it's going to be square root of 7, right? Plus, then it's going to be 2. That's going to be negative 3, right? Then if you say 7 plus, right, 2 open bracket negative 3, you're going to get your answer as being 1. So this is going to be the same as root 1, which is root 1 is the same as 1, right? So that's going to be your answer. What do we see? We see the fact that negative 1 and root 1 is not the same thing, right? So we see the fact that left-hand side is not equals to what? To right-hand side, right? So what does it mean? We can conclude the fact that x is not equals to what? Is not equals to negative 3. So that's how you would solve this question.